a good evening. Food hopefully was good, drinks at least enough and good. And yeah, good morning. Thanks for waking up in time for the first session. Yeah, I would like to again thank to our sponsors allowing us to organize another editions. Cipron, Gilava, Diabolocon, Cmood, Sipgate, QXIP, Pascom. They are here again very early, and the recording of the yesterday is already on GitHub, and they already made the index, like table of contents, so you can jump to each session. So it's not cut per session, it's a single video, but with like a table of contents, so it's easy to go to inside the video to the right position. So thank you, Jan and the team, Pascom, for everything you did yesterday. Snom, we gave yesterday a few devices, phones, and we still have a few today to give away. They do all these kind of devices, mostly SIP phones, but also DEC phones, if you want to check them. And yeah, our partners, Glucon and API ban, plus LOD, so API ban and LOD are actually related. Fred here helping us with cloud solutions. So today it's the first session today, it's more or less open discussion in the way that I'm coordinating it. And I see not many Kamailio developers, so they had a long night, but we still have many here, like Tori, Fred is here, Henning, Xenophon is hiding because he doesn't want to have questions, I'm joking. Andreas in the back, Federico, I saw it in the morning. And then we have also Pascom guys can answer, like Sebastian and Thomas, it's author of 2 modules or so, or at least 1, if I remember correctly. So we have Jonathan there, it's also with the new modules. We'll have a presentation about his work just after this session or so. So there are many developers here that could answer questions. So it's not me that I have to answer, of course. I can get another, maybe, and let's see who wants to help. Henning, do you want a second one? And maybe you cover left side, I will cover right side, and to do 2 kilometers of walking. So yeah, you saw yesterday a bit of summary of what's happening in the development, but this it's question about whatever you want to ask. We expect to be Kamailio, but of course you can ask integration with Asterisk. They do with like Gilava, they had the presentation. Alexander is here with Homer, SIP capture, and so on. So practically any question you want to address. Who wants to start with questions today?
Still sleepy, everybody?
Okay. Tori, you was early here and...
All right, so this is a question about the SIP capture module in Kamailio. One thing I find is that when it relays the HEP, it's not often the final message. Like it will send before the topology hiding happens, and also there's if you do modifications in the TM local route. Those modifications, if you add headers there, those are not appearing in that. Is there a way that you can tell that module to capture at a lower level?
Okay, I think it's about SIP trace actually, because capture is receiving, SIP trace is forwarding.
So Andreas is also here or not? Normally you can use event socket, and in event socket you can get a regional message before it's go out. Yeah? So. And you can send it as you received, and after modification you can send it twice. This is what you want, yeah?
Yeah, but I think you mean about your agent that takes it from... In Kamailio? event route, okay. Yeah. So, okay, I just don't, because I work a bit on this one. There are two modes actually. You use the mode with flags in the config, like set flag or so. If you actually want to mirror everything, okay. Because with mirroring everything, there is a module parameter, yes. And then it's doing at the right place. But if you use config flags or functions, then yeah, you have to place them at the right location. As he says, there is a event route, but the event route might be from zip dump module, because that one can write pickup with incoming and outgoing, and also can execute an event route. And in that event route is kind of the what's received and what's sent out for sure. And then you can have condition on probably source IP, destination IP. You can also match on method eventually and some other stuff. But if you use the dialog or the transaction mode, then it was a single contribution from 1&1 Germany. This year we don't have, last year was Lucian here, so... No, it's supposed to duplicate on a TM callback if you use the flag method.
Yes,
it's supposed to do...
I think there's a transaction method and a dialog method, right?
Yeah.
You can also do the dialogues.
There is a function. If you want to mirror at that moment, you use the function. If you want to just mark for mirroring the transaction or the dialog, you use the flags mechanism.
Okay,
okay.
Somebody on this side, maybe. No pressure, I come. Everybody.
That's good. That means we have good documentation. Someone was complaining yesterday. We have Stefan here. He's also a developer, so he might have to answer himself.
Hello, so my question is related to this topos module, and my problem is it exposes those event routes, incoming and outgoing, where you can drop. But for example, on the incoming event route, you don't know where you want to route that message. So for example, if I dispatch to some internal core, I don't want to do any type of topos. My question is, do you think would make sense maybe writing a new topos module that would will expose a config function, and from config you can choose based on where you want to dispatch your message if you do topos or not? Or maybe it doesn't make sense due to how SIP protocol works in general, due to those headers that needs to be
But I think you can drop it on the event route. It's called twice, and actually there are 4 of them. One in a lightweight mode that is not parsing the message at all, and you can have source IP. But then there is an equivalent for outgoing, and you can do on destination IP. And you can still skip it for the initial invite, and then should skip all the topos. That is supposed to work like that, actually. But yeah, if you want to add a function to mark it, then it's open source. Like deleting it from...
Yeah, I want to skip the incoming part and not do it all together, based on some routing decision, dispatching decision.
I mean, the incoming part is run with these callbacks and everything, so actually it's difficult to do, right? I mean, when you want to decide how to skip it, right? In the core you cannot decide because you don't have access, right? So it's a bit of, yeah, chicken and egg problem. How to actually decide how to skip without any information, because you need to process it through the core to actually decide if you want to skip it or not, right?
Yes.
I mean, again, it's open source. Practically everything is possible. I used to say that if Kamailio doesn't support something, it's because you haven't contributed yet. Now I could say probably because you haven't spent so many tokens on NI to do it yet. Because of Giri saying he put 8 hours of tokens. Or
Tori, I found another solution. You can use hlog. So, and before you do some modification, you can send this hlog zip message to Homer and collect it. So it will be original message, and after you will get modified message.
Okay. There's a function here, hlog, but okay. So, come on, the left side should.
Yes,
be
the left
marked.
side. I'm asking already.
Okay.
Yeah, perfect. Thank you.
Daniel.
Hello. I have a question about Homer. I'm wondering if someone here managed to insert into Homer other protocols than SIP. My interest is if someone managed to insert diameter interfaces.
Does Homer have support for diameter?
In agent, we have support for diameter. You can send diameter, but the problem how you will correlate with zip messages. Yeah. So it's this is a problem. So normally by host name you can do lookups, etc. But yeah, it's possible to send. It's if I remember, it's port 53 and protocol 53. It's called in Homer. You can send and store it and display it. It's even in Homer 7. It's supported.
So there is some support, but apparently no correlation with the call. So that's something you're gonna make a pull request soon. Okay, thanks for the questions. Anyone else that would like to ask? Could be also a new feature that you think of for integration with something. Not AI eventually, or AI, I'm joking. If not, yeah, we can also discuss a bit about the future. So we had quite some work on this, let's say, multi-threading and, a bit of scalability from the resource access point of view. In the past and even now, it is this question about too many connections to the database because it creates so many sockets or so. And yeah, this multi-threading, at least for UDP, helps to reduce the number of workers and implicitly the number of TCP connections to the database servers. So that's something that could be useful. We said yesterday some work for the ARM platforms from Victor had the presentation about DMQ, but he contributed there. And yeah, security, I don't know if I counted or it's actually evaluation, but I think we got over 30 the last 2-3 months, like
that was a lot.
reported like 15 or more.
Yeah, already in the last 2-3 weeks we got like 10, 10 reports, so a lot of, like not 10 individual submissions, but like 10 different places where people found things. Thankfully mostly in less common modules, I would say. Yeah. Of course we are looking into it and it will be addressed from the team.
Okay, anyone other ideas? What I would like to improve actually, and maybe some of you here can help. We have this Docker-based kind of testing framework. It's not really fancy, but instead of just having some shell scripts, it's everything kind of running in Docker. Giacomo there helped in the past a bit with Docker and test. I'm not sure how many are, not so many, maybe 30 or so. But yeah, because I think Dragos was saying yesterday that adding tests is important, but he's not here. He was afraid of questions about IMS and so. So probably will arrive just after this session as he lives around in Berlin. So yeah, adding tests, we have Ivan.
Just have a question, maybe feature-wise. So when dealing with SRTP and integrating Kamailio with RTPEngine, so Kamailio can monitor by ping with RTPEngine to see if RTPEngine is up. Now, if the RTP engine goes down due to SRTP, you can't just flip to another RTP engine. So you have to reestablish the calls for the media to be renegotiated. Now, is there any elegant way to have Kamailio initiate that? Or because I haven't been able to find one.
There is dialogue with requests within dialogue that could be, let's say, leverage, and then the TM has some lower layer API that you can send also requests within the dialogue. But probably we'll have to do a little bit of storage or do the reinvite without SDP, so then they do it themselves as they do the reply and the thing is that Tori discussed a little bit in the morning. Apparently this request within dialog function doesn't track CSEC updates. That should not be something complex. So I would say the foundation is there, like the pieces, but you'll have to build it, and if something is failing, might need a bit of hammering from this perspective. But I saw that the RTPEngine keeps also the keys for the session or not, for when doing the failover. It's not in Redis. It keeps the session keys in Redis.
No, you can. I mean, you can use Redis with these table replication to do it. It's not so easy to set up, but you can do it. You have like a primary Redis table and like a secondary Redis table, and then if you have a failover, you can move it to the other Redis table basically, and the call can continue. It's not so easy to set up, but a few years ago there was a talk from the one-on-one guys, right?
Yeah, one-on-one.
They're using it in production. Yeah, it's not so trivial to set up, but it works.
I mean, not easy in the way that the documentation could not be there. You just look at the code. But it's using Redis to keep the states. Andreas maybe can add more, but I remember that I saw something. It's why I was a little bit reticent about whether we really still need something Kamailio or with this Redis-based replication in RTPEngine. Everything is fine because the keys should be per session.
Yeah, I mean, there's like a host key, maybe if you want to call it like this, right? If the RTPEngine starts up, it generates, of course, an own key, but the session key are something different, right? They are per session.
And can reuse the session key from the other.
In the session. Yeah. But for more details, we probably need to ask
Richard, which is now in
Richard or Andreas.
Caribbean island somewhere, so he cut the submarine cable for today, so nobody can reach him. But yeah, should be there. Look first on that one. If not, let's be in contact, and I could give more direction. Because in the morning when Tori was here, like 5 a.m., we discussed a bit about this not tracking dialog CSEC update with the request within dialog function, which was added by Karsten Bock, if I remember correctly. Karsten used to come here. It was on the picture, like former IMS guys in the project now doing AI stuff or so, as I could see on LinkedIn. Other questions? We still have not so many minutes because I don't want to be, so like 5 more minutes. We have, it's there. Next.
Where? Ah, okay, sure.
Hi, I wanted to ask you about it will be possible to reload the roots in the config without restarting. I know it is possible only if you use other scripts to, like Python.
Yeah, that's sometimes coming back, and at the end, it's again about coding, and nobody took that task to do it. lately, like past 10 years, I focused a lot on KEMI, and it had support from the beginning to reload. Mainly because, the new generations was using more this Python or KEMI scripting because they know the language eventually from other documentation, and it's easier to, let's say, start with it. And the older config, because I had many presentations about native config file and KEMI scripting, so when we add a function, practically it's easy to export it to both of them. And config file function, it's usually like a wrapper around KEMI function. But we haven't put the effort. At some point I was considering to do a quick hack to just put it in shared memory and then make it easier to swap the like the pointer to the active config file, but I never got to it because, I mean, usually if you restart, it's very fast. UDP, you don't notice. Yeah, everyone is afraid that if it's a production, you can't really do it, but a lot of applications restart automatically. But in telecom, somehow people think, restarting whatsoever. So can be done. It's not there. I don't have an immediate plan to do it because when I need it, I typically go for Lua these days or JavaScript, which is a module without external dependencies, and then reload it's there. So these days, practically, let's say not so many new deployments because the market is established, but it's like half-half. Native scripting usually for small kind of deployments, but then Lua, Python, JavaScript, it's quite common. So might be there. Let's see how much time we have. Sandro?
Yep. So, like any successful project out there, I think you guys are getting more security reports, right? So more vulnerability reports, some of them probably good, some of them not so good in terms of quality and real, if they are real security issues or not. My question is, how do you plan on handling this? How are you handling this? Are you going to group them all in one release, for example? And how are you assessing these things? Can you talk a bit about what's happening? Where you can talk, of course. I'm not asking you to reveal any 0 days.
So, just to start, maybe then Henning will continue because he's also involved. We have this security group that I mentioned yesterday, and we should increase it. I think we are 5 now. It's Fred, Henning, Victor left, myself, and Ole, right? If I'm correct, Ole Johansson. And it's where we get the reports. Then someone usually reacts quite quickly, acknowledging, okay, we receive it, thank you for your effort, and so on. And then we try to distribute somehow the work. It's not like some CRM or a manager. Someone takes over, and the main question would be how much to disclose sometimes, because telecom market is freaking quickly if you have an issue. But we have internal kind of project where we put our possible solution and so on, and then we decide what word to be as a CVE from all this, because many of these reports come like highly critical issue in SMS module, which probably nobody uses. From ages you need a serial port or so. But we keep it like for historical purposes. So it's using the AT modem that you need to connect to Kamailio server. Some modules are there. We started to archive just to reduce a lot of not necessarily security, but there were a lot of like warnings with the new compiler versions, and we knew were not used. And Then, yeah, also if it's a module that should be used after authentication, yeah, if a trusted user, a subscriber, tries to hack you, he can make also calls and then, you know, like don't pay and disappear or whatsoever. Some you need to trust a little bit. Of course, you need to protect as much as possible, but we consider them as lower priority. While that if anyone can send something and crash in Kamailio, of course, it's high priority. Because also this process, and Fred enroll with this process of reporting CV, writing first to a company, no response, you wait, you give reminder. Then we went with this GitHub reporting.
Or the CV creation, yes. Yeah.
Because I guess those companies were also overwhelmed with a lot of reports eventually.
Yeah. I mean, good.
So like Daniel was saying, there's a security group. We discuss it among ourselves. There may be disagreement even on that. It also gets talked about on the management level sometimes. When there's an absolute critical release that can affect everything, that we will issue generally a new release. And CVE, like that just happened, as everyone knows, we had 2 CVEs. That process was enjoyable. But what Daniel was alluding to was, you know, we tried to do it through, in the past, most of our CVEs was gone through Mitri, or however you want to pronounce it. And they didn't even respond to us for 2 weeks after we submitted it. So we ended up, yeah. And so we ended up, since we're hosted on GitHub, GitHub can now issue CVEs. And it was a process.
48 hours, it was quite okay. No?
Yeah, and when I first released it in the draft mode, of course, because of our setting, it was announced to the world. But so we've corrected that. But I think the GitHub method that we have now in posting the CVEs there, I think works pretty well. I'm pretty happy with it. But yeah, I mean, we address them quickly, and then we do releases, and we try to work with the reporter to make sure that, you know, if we do need more time because of the seriousness of it, like this last one of the CVEs is, I mean, it was quite old
15 years
the code, yeah, and you have, sadly, because of the stability of Kamailio, a lot of people just simply don't upgrade. And so, I mean, you know, we want to try to, we work with the reporter to see if we could give more time, so we could give notices to companies that we know are using it, that have an older version, that they do need extra time to implement things like that.
So maybe just one little thing to add. So there were also some investments from different developers, from the open source, from the team, from the core group, to extend the fuzzing as well, using the OSS fuzz from the Google. So you might or might not know, and this is also quite helpful to proactively address some issues, I would say. There are also other researchers who are fuzzing, not publishing security reports, but just improving general security of the project.
So, like escalation, to summarize until Jonathan sets up, because we now are a bit late, but okay, no issue with that. So it's security group. We kind of do a triage there, select the important one when it's very critical. The next would be, we have so-called management board, which is not always just developers that understand the code, and then from there it's maybe another decision. And if it's really critical, those people in the core of the project, the developers that we trusted, are notified as well. So security and management then close developers of the core. And we advise everyone to fix their deployments if they run it, or advise their customers to update. And then we make it also public in the way that, hey, the next release is important, or the last release is very important, you should upgrade. And 3 weeks after we released the CVE. So that was
Yes.
the process for the last one.
Yeah, but in general, every minor release contains important updates, also on the security side, even if there's no CVE. This is important just to know, and if you have an important production environment, it's always good to use the latest minor version.
Sometimes I get from mailing list, but like private messages saying, hey, I saw this kind of fix, can I get it in the minor release 2 editions ago? I said, yeah, but that's actually in the same series, would be like just migrate to the latest version. No, I want it, that version released with a new patch. I said, that's not possible. That's a snapshot in time, you know. Once we release like 601, that is, and they come later when we have 605 and saying, can you release that one, but with this patch? I say, no, it's not how it works. If you want to do yourself, check out, cherry pick, but we can't rebuild the release. That's it. If it was somehow broken or regression, this is, okay, quick thread. And
yeah, I mean, there's lots of changes that happen all the time, and we highly recommend that when a new release comes out that everyone upgrades. We support the last 2 versions, so right now it's 6.1, 6.0. 5.8 will get some security updates as well, but update. Pascom went, and they discussed their process of, they put the time in to make the updates easier, and then the updates are easy. If you put in the time to make it easier to update your system, we highly recommend. New software is coming out, AI is attacking everything, and it's a good thing to keep modern.
Okay, so thank you everyone. Yeah, we warm up later. I thought it's gonna happen like that until people got into the mood of speaking. But I want not to delay it. We are like 5-6 minutes already. I'm ready to welcome Jonathan. That he and maybe alone or with some colleagues, they contributed 2 modules in the last year, in the last release. They came also to Düsseldorf at the Devel meeting, so they are quite active, let's say, in the community, at least the last year. Thank you for coming. Looking forward to your presentation, Jonathan. The floor is yours.
Thank you, Daniel, and thank you for having me. It's a really nice and contentful conference. Today I will walk you through how we rethink notification using Kamailio with Arnacon in the ecosystem. The goal of today's presentation is to show you how we can remove complexity and prior trust assumptions and long and hard integration time required to set up a system like this. My name is Jonathan Kandel, and I work in Select. Select is an MVNO in Israel, providing secondary numbers inside an app for experience without supporting physical SIMs in the last years. We moved everything to be virtual. We've been using Kamailio for many years and in order to integrate telephony systems. Over the time, we experienced complexity and a lot of hard integration and operational challenges on the way. So we took all of these problems and we wanted to bridge and build a solution that will help us to remove any hard and struggles. And by the name of Arnacon, this startup started in the Netherlands 4 years ago. And since then, we are building Arnacon, and more about it later. Elena yesterday explained a little bit about what is a notification in SIP. I will also briefly talk about it. It's a telecom notification is not just push messages. They include SIP signaling and variable information that the phone needs in order to register when it's offline. So for example, a user is coming and wants to send a message to someone and that device is offline. We are sending him a push notification to wake him up and let him know there's something that he needs to do. There are 2 types of notification systems. One is APNS for iOS devices, and the other one is FCM for Android. Until now, in the traditional way, we've done notification as following. A user initiates an invite, then the Kamailio gets the invite, and he authenticating the user with a local pre-established trust database, if it's a Redis or if it's a MySQL in the past. and with an RFC 2617 that we all know. And once this authentication is completed, the Kamailio gets the state. Then he uses already stored credentials that the Kamailio have, and is making a request to a trusted API, letting know the API that we want to send a notification to the other recipient to wake him up. The trusted API gets the request, is validating the credentials or wherever it is, and then the trusted API sends the notification to the relevant notification channel to broadcast it directly to the recipient user, and returning then a response that will later be used to the user. Then Kamailio depends on a local database and provides a local and trusted API that needs to be pre-configured and pre-established trust between them. Each integration is manual and required and repeated. In Arnacon, we're doing this by a user is sending an invite, again, sending to the Kamailio server, a cryptographic signature that can be validated with the user identity and fetched dynamically from a decentralized cloud. We contributed a model that is off Web3 that allows to validate and authenticate the user as the following. As you can see, it's really similar to how the normal off model is being run. The difference between them is the off Web3 model is not being validated against a local database, but rather fetched dynamically into a decentralized cloud. After a successful verification is being done, we can move to the notification. Kamailio is making a request to Oasis Sapphire in order to request some notification details. This is where we are making some big changes, where the Oasis Sapphire, it's a decentralized cloud functions that allows different service providers to upload their secrets. For example, their APNS, FCM, private tokens, and securely into a trusted execution environment. This allows this decentralized cloud to run code for us without revealing the secrets that we pre-uploaded. So every service provider can come, upload their secrets, and then the Kamailio can make a request to the signaling plan with this, all the relevant details and the notification type that we wanted, and then returning back the steps required for that plan to be executed. And this decentralized cloud to generate a JWT that can be later exchanged to an access token can look something like that. If you can see on the right side up, there is a get APNS key that is the specific service provider pre-uploaded key that can be used to sign the request that can be later be broadcast to the correspondent notification channel. In this case, this is an example of an APNS. After we get the request authorized and delivered back to the Kamailio, it's without still broadcasting it to the corresponding notification channel. We can send the notification from the Kamailio directly to the notification channel after we make some small operations on the Kamailio side, like exchanging the JWT to an access token with Apple or with Firebase, and then sending the notification to the corresponding notification channel. Then we get the response, and we are returning it back to the user. So why does it matter? Because there's no more local database that is coupled with the Kamailio instance. We removed the integration cost because we don't need to maintain a remote API. It's much more secure because we don't need anymore to maintain or have a one-point failure system because it's decentralized. And it's easy onboarding for new service providers to come and upload their own secrets, and then everything that is pre-established and configured can be used forward. Now a user that is registered this way can receive Kamailio trigger notification from another service without that service owning the user's authentication record before. We removed integration heavy to a plug and play components. where telecom can be just as easy as a trustless authentication. The notification channel and the authentication are decoupled components that are no longer needs and relying on one another. So the Kamailio becomes the place where telecom apps can run. What we just saw, it's not just a feature, it's a platform we can all build on, where we separate authentication, notification, and the communication from one another. Arnacon brings trust into a trustless environment, where we don't need to establish trust between parties before communicating with one another, where the user identity can be cryptographically verified and can be as simple as a cryptographic wallet. Service can communicate easily without deep integration. So the Kamailio state becomes making it stateless. So it's easy to have a load balancer making up and down without needing to connect it into a specific database or an API. Let me do a small recap what actually changed from the traditional way into the new way. In the traditional way, we had a local database that we needed to validate the user's authentication, where in the new way, we validate dynamically with cryptographically way. In the traditional way, we had to store credentials and validate them on the remote API, where in the new way, we are retrieving them dynamically with this decentralized confidential cloud, and the Kamailio itself broadcasts the notification to the notification channel. So in the traditional way, we had tight coupling between all of these systems, and in the new way, there's no more coupling, so the integration becomes super easy to onboard new service provider or new integrators that want to enable services. I'd like to show you how a full structure of the ecosystem looks like it. On the bottom, we see that this is the Arnacon protocol that acts as the foundation layer where identity, trust, and verification lives, where coordination between parties is handled. This is the foundation that everything relates on. On top of it, we have the communication layer. This is being in charge by Kamailio. Kamailio handles the SIP signaling, the routing, and connects service providers, carriers, and operators. It manages the service provider settings, and it's interconnect between networks. I like to think about it as the traffic control of notification flows, of communication flows, sorry. But something is missing. All of this infrastructure, but how users and service providers can actually use it. This is why we built the Arnacon app. It's a runtime telecom service. It's the experience layer where services become usable. This is where the UI lives. It's a client without maintaining a SIP client. It enables provider to launch their own application with their own look and feel without their need to maintain and operate it. Arnacon protocol provides the trust, where Kamailio provides the communication, and the Arnacon app turns all of this into a usable, experienced services. I will focus a little bit about the Arnacon app, where we realized in this point that we're not building an app. We're enabling many services to be run on that app. Then the Arnacon apps become a phone where telecom apps can run on and installed. Then if the Arnacon app become a phone, then we need a place to download applications from. And the best way to describe it is like an app store. It's, we call it the app store model, where services can be installed into that phone, into this app. As well, if you have already your own app, then there's an SDK that can be supported as well. And the Arnacon app, it's the runtime environment for these telecom apps. Once you install Arnacon, it instantly supports future applications, like a phone supports new apps when they're being uploaded to the App Store. There's no more hard integration cycles, and there's no more backend app wiring required when new app come along. Everything is a plug and play to the authentication, communication, notification layer that I presented before. I like to think about it that if Twilio enables API communication in the backend, then Arnacon enables them in the front end. These are just some of the examples that we see that Arnacon can be used for. The secondary number is an application that Select in Israel is selling virtual numbers to customers, where the initial time estimated to build a new app from scratch right now would have been around 10 months. We recreated this app inside Arnacon, and we managed to reduce integration time to less than a week of creation of this secondary num. And an installation will look something like this. Here we are in the service provider store. For that, it's the secondary number for Select. We are here being moved to the checkout. Here, the service provider decided to use Stripe for the checkout for the payment provider. After a successful payment is being done, we are being redirected back to the store. The service provider validates everything, and then is generating a QR code for the installation or a deep link inside an email that can be later clicked on. This behind the scene, what it is doing, it's using the Arnacon SDK that is directly making a request to this decentralized cloud in order to write the user's identity inside. This payment and the installation inside the app that is now being done is decoupled, so we don't need to pre-configure anything before. Now it's inside the app, we are scanning, and then this is just showing how an activation will look. The service provider validates whatever he needs in front of his services, and then once everything is ready, the application is now installed inside the app. So now we have a secondary number inside this Arnacon app. And now we can dial. This specifically is how Select, the SecNum, decided to have their own dialer looks like. But we can have multiple applications that can be also installed in the app besides this secondary num with different service provider, not only Select, it can be anybody that wants to have their own app installed. Another example is the Light PBX. It's a lightweight PBX that can be configured and run for small businesses in under 5 minutes for call transferring, redirect call, voicemail, IVR routing, or multi-ring for small businesses to interact. Different services created their own application with a custom. We can see, for example, on the left side, we have an eSIM company that deployed their own white label application with their own look and feel on top of the Arnacon runtime and installed calling model into it. On the right side, imagine Kamailio World launching their own app, their own event app, or a place where the community can interact. We can get real-time notification if a room is changed, and we can know where the drinks of tonight are going to be. This changes everything because we no longer need to maintain a SIP client. We don't need to maintain or build telecom apps from scratch. We can rely on simple plug-and-play integration and build from there. Integration costs drop significantly, and time to market become dramatically faster. Companies can experiment with new services with minimal risk, because until now, if you wanted to deploy their own app of a secondary number or a new product stream, it would require you months and a lot of money and a lot of people, And with this new model, it can be done in less than a week or even less for some other applications. We're enabling value-added services and direct-to-user telecom services. And we cut the middleman on the way. So you sell directly to your end user and install it in the app. The bigger picture is we're not building apps. We're enabling a place where apps can run easily. Here you can see a picture from the Arnacon app that installed a light PBX for my ice cream shop, an eSIM for global telephony to when I flew to Bali, and a secondary NAM in Israel so I can call inside. And we have some other products that we installed as well. So every service provider can have his own app still installed on top of the Arnacon runtime and can still be managed and adding new products when they're launched. So users gain capabilities instantly when new apps come. Traditionally, Kamailio used as a communication engine. This is where we are turning it into a platform for services, for telecom services. Then instead of building new features into the infrastructure, we build on top of it, and Kamailio can run them. Thank you.
Thank you, Jonathan. And yeah, looks something that would make it easier. My concerns are always about adoption of these things in telecom. It's not easy, but you are here. And then Andreas.
I want to understand how the revocation work, because like in the Kamailio world, right, like earlier, like if a user reports a compromise, you just delete the user identity from the DB, right? But how does that work here in the decentralized?
That's good.
Authentication right now is being done cryptographically. So every product, every identity has a cryptographic wallet, a key pair that is used by some other like cryptographic curve. It's a Lichty curve or Edward curve. That's like a typical Ethereum curve or Bitcoin. And then this user that he owns this key pair, this identity, he can prove that he is the owner of that key pair for a fact. And if later there's like misconduct or he misbehaves, then it's no longer the Kamailio, the one that enforces this. It's the other client, the end user in the end. He can decide that he blocks communication or traffic from that people. We're making the Kamailio more as a communication traffic controller rather than deciding who enters their own house.
Thank you for the presentation. I have two questions, actually. The first one is from an end-user perspective. So you were saying you can deploy apps in your ecosystem. So in the end, you still need a native app on your phone to receive push notifications, right?
Yes.
Is this the Arnacon app where I then can deploy my own app into it, kind of, right? Or how does that work? Or does every customer, every brand gets its own native app? That's number one. And number two is, what's the advantage of having this kind of authentication in the blockchain versus you managing it on your own central databases?
Okay, that's a good question. The first one is, you said about if you need your own app, right, to run, then you can, if you have your own application, you can just plug and play with the component I saw with the Oasis Sapphire that access this decentralized cloud that can hold your private credentials. So if you have your own APNS, your FCM tokens, everything, you come and you uploaded it there as a new service provider, and then you can, the Kamailio that is already configured to use this much bigger picture protocol can use it. We just developed the Arnacon app just to have life easier for other developers that want to directly plug in new services and deploy it. But there's also an SDK that we developed, and you can plug it into your application directly and use it. It's still, all of this is, we are experimenting. We are doing a lot of proof of concept team, and we are doing some now alpha developments with some other small companies, and we see how it's going with, like what we showed before, the eSIM company. We're doing a pilot with them and showing how we can enable local telephony inside the app, because they decided they don't want to develop and maintain their own app. So they took the Arnacon as a whole, and then they installed running the calling model into it, and you can still look at your eSIM data that is like quite of the most ideal ways, but there are so many others that can be done.
Okay, for more details on this one, quickly the second question with the central database, because then soon we'll have the data break and then you can discuss more. So the second question was...
What was the second question again, sorry?
The advantage of storing authentication data in the blockchain versus your own.
Yeah, that becomes just decentralized in like the bigger picture. So none of people need to have their own database that they need to maintain, their own API that needs to maintain. And when scale becomes an issue, when you have a lot of users, an API and request, there's a lot of failure point, and you rely on a Google or AWS. We did all of these things, and we are dealing with operations all of the time of the installation didn't work, this is not functioning, the SBC, everything, all of this blocked. When we are moving into a decentralized cloud, we no longer need to maintain it. So operational just becomes almost zero. And if a Kamailio doesn't always
okay, this will have to, operation zero is something that I'm always done. But might be the case. Let's discuss it the breaks or so, because yeah, we're a bit late. We started late, so no pressure on Sandro to finish in 5 minutes. Until Sandro gets... thank you. Sorry. So he's already set up, but yeah, I haven't really said it so far, but the reason for these shorter slots is that when Sandro got longer slots, he scared us that everyone at the end was like just doing upgrades and not paying attention to other speakers. So not to induce too much like fear in us. I'm joking, but yeah, you probably know Sandro with the Vicious friendly scanner in the very old days of the voice over IP, doing security research, reporting to many projects, including Kamailio. Sandro, thank you for coming and for your work on securing, let's say, the open source side of telecom. Thank you. The floor is yours.
Thank you, Daniel. So, yeah, I'm here to give an introduction to a new project of ours, the VRTC. Yeah, before I start, I should introduce that, yeah, I run a company called Enable Security, and we do penetration testing in voice over IP and WebRTC security. So, security testing of the sort of stuff that you guys like to build, or hate, I don't know, but, you know, like to build. So, this is the VRTC introduction. And I have 2 demos, very short time. So I'm gonna rush through a little bit. Sorry about that. Let's start with the demo, because I guess, you know, that's what you're here for. That's what you would like to see. So I have a SIP to SQL injection or SQL injection in SIP demo. To start with, and then I will explain why we're starting with that. So, let's say you have a vulnerable Kamailio configuration, and essentially you have the user agent header, which is being, you know, used in an SQL, a SQL query. We're using the SQL underscore query function here in Kamailio configuration. You know, it's the backend is actually a MySQL. And you'll notice, yeah, if you generate an error, it's gonna at SQL level is going to give you SIP 500 response. We called it ouch here, but it could be, of course, anything. So if an attacker sends a single quote with in their user agent, the SIP message, which is attacker controlled, then they can break out of the SQL string and, you know, then they can append their own commands, SQL commands, and maybe you know, use stacked queries, and so on, with a semicolon, and so on and so forth. But instead of doing this manually as an attacker, you can also use open source tools like SQL Map. Now, SQL Map is a web application penetration testing tool. It's not really, doesn't know SIP at all. But SQL Map is an excellent tool for exploiting SQL injection vulnerabilities. It's really cool. It's, there's a lot of work has been done in the past probably 20 years on SQL map. So it's a tool that we can reuse if we have a SIP to HTTP sort of proxy. And that's what we have here. So we're going to have, in the demo, we're going to have a harness that translates HTTP requests into SIP register messages with crafted user agent headers, which allows us to use this excellent tool together with a vulnerable Kamailio configuration. Now, obviously, just keep in mind, this is not a built-in vulnerability in Kamailio, just, for those people who might think so. And this is just a vulnerable configuration. Anyway, and the point of this tool is to be sort of an oracle to say, yes, the SQL query worked or not to SQL map. I'll explain a little bit soon. Oops. So let's do the demo thingy. Mouse. And then, yeah. All right. So, yeah, I'm going to check that WebRTC is working. It's a Docker Compose build thing. I'll be going into more details into this soon. And then we start a testing shell, which is comes with the whole package. So the package has vulnerable and also testing tools. And we're going to start this SIP to HTTP tool harness, Oracle for SQL map, which starts an HTTP server locally. And then you can point SQL map to that HTTP server, and this HTTP server locally is talking to SIP. So the video is continuing, yeah. So yeah, that started in the background on a high port. And then we're going to dump the customers from the database. We're going to specify the database type, but SQL map is really cool because it does this pretty quickly, and it starts getting character by character from the database by using some, of course, it has a lot of tricks built into it. So to replicate SQL map is quite hard. Yeah. So once it gets all of that, where are we? No, where is he? Ah, yeah, okay. Going to skip to the end. All right, and at the end you get, the database dump, and this is very practical. It really works really well against web applications normally, but you could get it to work against SIP if there's an SQL injection vulnerability that is exploitable there. Now, let me switch back if I can to here. Okay. Now, and the way it's working is something like this. You have this Boolean SQL injection tool that asks many yes and no questions. That's essentially SQL map. And the harness makes each yes and no question travel through SIP via the user agent path, right? The user agent header. And the 500 responses are enough to tell if there's a database error or not, or the Boolean signal, essentially. And just to remember how it looks like, the query looks like this. All right. Now, this is something that we've seen in practical, pen tests. But why am I showing you this? Well, normally you would have to take my word for it, right? I would demonstrate this like I did last year and say, okay, don't do this. do this instead, right? But you have kind of no real way, no practical way to reproduce this for yourselves like easily, right? And the VRTC is there to help with that. So it's public, the source code is available, you can go on GitHub and check it out, you can run it for yourself, you can, there's a public deployment as well, pbx1.thevrtc.net. So the whole idea is that it's intentionally unsafe. You should not run it on your, secure networks. Keep it isolated, ideally. But it allows you to see for yourself these sort of vulnerabilities, play with them, learn, and so on and so forth. So it's really, really cool to do. So what is the VRTC? Well, the security community has kind of a lot of projects which are called Damm vulnerable something. Damm vulnerable web application is one of the most popular ones. A lot of people in the security community, cybersecurity community, have started their career learning from DVWA, the Damm vulnerable web application, for example, which is a set of PHP scripts, a web application. I don't remember exactly, but it might simulate a bank, a vulnerable bank, and you're playing around with that. And the idea is that in voice over IP and WebRTC security, we didn't really have something reliable like this, and now we do. So that's what the VRTC is here for. It's a safe, reproducible target for real RTC attack practice. And PBX1 is we have different scenarios. So PBX1 is the first scenario that we have, and it includes Kamailio, of course. That's why we're here. There's PBX2 as well, but of course I'll be focusing on PBX1 in this case. So PBX1 stack consists of Kamailio. It's on the edge. There's also a WebSocket interface and so on. So there's various different interfaces. There you can test SIP TLS and so on and so forth. We try to support as much as possible on this architecture. Then there's Asterisk behind it, RTPEngine on the front as well, Kontron, MySQL on the back, and Nginx to help out with some vulnerabilities. And it's all running from Docker Compose, so you can, just easily start it up. So in terms of diagrams, we all love diagrams, right? You have Kamailio on the front, but of course, even though Asterisk is behind Kamailio, keep in mind that, like in practice, a lot of traffic gets sent to Asterisk, and so just because Asterisk is not exposed, if there are vulnerabilities in your Asterisk configuration or version, they're going to be exposed probably at some point in time, through some SIP messages, maybe behind authentication, but still, it could be a problem. Anyway, this is a pretty standard architecture, I think. You'll see this in some shape or form in practice. In our work, we see this a lot. Now, how to run it? You get clone, and you run a few scripts to initiate certain variables that are necessary, but then you run the compose script with the scenario and tell it to go up, and that's basically it. We use Linux host networking and large UDP ranges, so we don't really support running it on Docker desktop on macOS or Windows. Use a Linux VM in some way. There's instructions in the documentation as well about this. All right, in terms of attack surface, the PBX1 supports roughly 12 exercises or 12 vulnerabilities. These are the signaling vulnerabilities that we have documented, and they're there. And you have the tools as well to test with them, right? With the whole project. So it embeds Subvicious, it embeds some custom scripts that we developed quickly and VoIP coded essentially for the project. But they work reliably and they allow you to reproduce these issues. And there's also media security issues that are exposed here, things with RTP. That you don't usually see so much talk about, apart from us. We're always very vocal on these things. And then there's the SIP2SQL that we saw, and turn relay abuse for WebRTC. So yeah, there's a lot of stuff that you can reproduce here. So, all right, more demos, because that's what you're here for. So we started with the SQL injection, but yeah, we have a second demo, which is about the digest leak. Now, the idea is that the attacker can, without being man in the middle, without having, sniffing the authentication mechanism, can force a UAC to send back the digest by authenticating to the attacker rather than to the normal server. And then we can crack that offline. We can use an offline password cracking attack against that. So we have these different components. We have the victim UA, which is a bare SIP. It's all the time connected. So inside DVRTC, PBX1, it's all the time connected as extension 2000. What I mean by connected is registered, by the way. Sorry about that. And then you have an attacker tool that calls BearSIP through Kamailio by sending an invite to the SIP URI 2000. And then you have the victim BearSIP, which hangs up, sending a buy. It hangs up every 2 seconds, essentially, so that we can reproduce this within reasonable time. And then the attacker replies with a 407 asking it to authenticate. And the main problem is here, right? Kamailio is relaying the challenge and the digest response to that challenge back to the attacker. So the challenge from the attacker to the victim is being relayed from Kamailio because it's configured in that way. All right. And yeah, because you like diagrams, I'm sure, this is how it looks like. It makes it more clear. All right. Let's do this one. So full screen and play. So yeah, again, we check that everything is running and start the attacker shell. We have a testing shell and the attacker shell both have the attacker tools. And then we can use Subvicious as VWAR to enumerate, just to show that the SIP extension 2000 is there. And then we're going to just use this tool, which does what we just described, right? So it just works, essentially. So yeah, it sends an invite. Then it gets answered by BearSIP. This is not a vulnerability in BearSIP, by the way, just to be clear, just in case there's some. And then BearSIP hangs up, and the tool sends a 407 proxy authentication required, which BearSIP is happy to oblige, and then sends the proxy authorization header in the by again. By sending it again, but with the header. And then we have this output for John the Ripper, which is a very, it's a tool that's been with the security community since forever. John the Ripper allows password cracking on the computer, offline, if you have a hash or a digest. And it cracks it very quickly, of course, because I just have a very short dictionary there. But yeah, it still is, even in practical terms, it would be, so if I stop it, it would be a very practical attack. It's relatively fast. All right. So let me see what I'm doing here. Okay, what's the reason for this? Essentially, the T relay over there forwards in dialogue responses, and this includes the external UA's digest challenge and the response. So, you know, Kamailio authentication would not fix this as such. You could have, we didn't have authentication here for the incoming calls, but if you have authentication, you could still, you know, if you have this sort of configuration, you could still have this sort of problem. And it's because Kamailio is, in this case, proxying, you know, things. It's doing its job, but perhaps we should have a filter there to make sure external UACs are not challenging responses. All right, so what's next? Yeah, I mean, we have a second scenario with OpenSIPs, free switch, and RTP proxy for those people who want to play around with that sort of stack. But PBX1 is the most complete one so far. It comes from we've developed this actually like 5 years ago or more when we were working on SipVicious Pro and needed something to test against. But of course, this has been polished a lot. We hope to have a third scenario with WebRTC native scenario, probably with Janus. We're still working on it, or didn't really start so much. Homer integration would be cool for those nice diagrams that you might want to see. And I really like Homer 11 now. It looks like a good idea. And that could allow us to turn this into more of a honeypot sort of thing as well, at least for our own use. But yeah, contributions are, of course, welcome issues. And new scenarios as well. What sort of attack paths do you see, you know, in the wild on your systems or on your friends' systems? What would you like to see in practice to play around with in here as well? So, yeah, maybe we have question time, I hope. And yeah, there's a QR code for a top secret URL full of resources related to this.
Until Iurii gets set up, Iurii, you got the microphone already?
Oh, and every month every month we issue a newsletter, the RTC Sec newsletter. It's unique in the industry because there's no security newsletter that covers WebRTC and voice over IP. So, you know, please subscribe. It comes out every month, and people seem to like it, seem to read it.
Okay, so the winner for the question, it's even more questions than in the break.
Just one quick question. I was quickly looking at the repo, and I see that you already have, for example, for the PBX2, you already have the solutions and guidelines on how to solve. Now, will you do something similar to the Damm vulnerable web app, where they just say what's available, and then people have to work on their own to solve?
Yeah, we provided the exercises, and you can follow through. I think, and I did that because I think it will help people learn better and quicker, sort of thing. While, you know, there's so much information about web application hacking, right? But the voice over IP stuff, it's not well understood from a stack point of view. They might understand certain things like SQL injection, you know, but yeah. So no, we're not gonna remove those exercises, I think, unless you're really asking nicely, but.
No, maybe you add more vulnerabilities, but no solutions, so that they
right.
force themselves.
We could do that, yeah.
Okay, thank you, Sandro.
Thank
You. We are a bit tight on time, and I know many people want
Yeah, I try to be a little bit shorter. Okay, so everyone, hi. My name is Iurii, as I said before. And coming to the question you see on the screen, I have like a short thing to declare. KEMI is cool. Yeah. Yeah, KEMI is cool. And basically, there are reasons why it's cool. And it's cool because, like, a main reason it brings, as Daniel already said, reload configuration on the fly. It delivers feature-rich language, proper language finally, right? And it allows us to use language ecosystem actually within your configuration. But if someone of you using KEMI in your projects, and if your KEMI looks like that, if your configuration looks like that, you basically don't use KEMI here. You don't have any advantage of KEMI. What you do here, you basically transfer your native configuration to language, some particular language, whatever here is Lua. You can use Python or you can use whatever you want. And instead of having all these features of KEMI, you basically have a lot of problems. And what kind of problems here you have? Let's look at into the next example. The first problem comes from this really tiny thing. Like you can see this, let's typo, yeah, lost road, some rose roads, lost road, something like that. And with native configuration, we can just start. We just can run Kamailio manage C, so checker, and what checker does gives us full information about where we are wrong before we go into production, serve the client, serve the traffic, and getting error, which is on the left side. Because on the left side, you will see this problem only once you run the configuration. So basically, you lose tooling. The second scenario, even more interesting. The second scenario comes from point when you done everything right, but for some of your scenarios, you forgot to cover some edge cases, like when, for example, header doesn't come, right? So here we see header comes, and the next example, we don't have any header. And what happens here, we use KSR pvget function, which by default returns null value. And then we apply null value to concatenation, and interpreter Lua will fail down in a production. And this you will notice only once you serve traffic. This is not the problem of KEMI. This is the problem of, actually KEMI covers all that. So we have plenty of functions which return you empty string, whatever else you want, empty string, as far as I remember, what else there? Null, as far as I remember, in a brackets as a word to have the same experience like you have with a native configuration. But the thing is that to know that, you probably have to catch that in your production. And the problem here is that native configuration, and once you migrate from the native configuration to KEMI, will never have this problem because of it already covers. So again, you lose tooling and you may lose customers as well. So we can say about it, so the only thing you can do is actually do proper testing, but you don't have tooling anymore. And even more, KEMI actually brings more than future-rich language. KEMI brings external dependency, which you barely can avoid if you want to use Kamailio and everything that's integrated in the Kamailio. So basically modules, functions, using pseudo-variables, using whatever you want. From the Kamailio comes from the KSR object. And what is KSR object? It's exactly that object which exports everything to your code. And if you use some external dependency, you have to, and you want to test, you have to test or mock this external dependency. Otherwise, you won't be able to call this external dependency from whatever else until you run the Kamailio. And mocks actually are costly thing, I would say, because of I've done mocking KEMI for Lua, and actually there is like a project place in a GitHub for 5 years for now. But the problem is that you have to mock keystar object, pseudo variables, modulus behavior, and you have to cover it in more or less exactly the same way they behave in a natural habitat, right? And this brings yet another problem that, see, look here. Trust to your code requires mocks, right? But mocks, is the code have to be trusted, right? So your mock have to be working exactly the way original function works, otherwise it's useless. And it's useless, you won't be able to have proper experience. And actually maintaining KEMI in general is really way more expensive than native configuration. However, KEMI brings a lot of positive things, like extending functionality. And the most interesting thing that you can use KEMI extend your native configuration. So Daniel was talking about it quite a lot, I believe, like through last sessions, because probably he also does this project where he needs to integrate functionality to parse some JSON objects or whatever. And yeah, here is a simple configuration, simple extension, which does, I shorted it, SIP to ISAP reasoning conversion through the KEMI, and that's one becomes way easier than doing this in a native configuration. And you can also easily test that. And you may see that we can call it from the Lua run. And the thing is, like, when you do Lua run, you aren't calling external script from Lua, which lays somewhere. And it's not like in a free switch in Asterisk, when you call external script, like Lua scripting, it's every time on each thread wakes up new virtual machine. So basically, KEMI done in a way smarter way, just because of the nature of the Kamailio, because of the forking nature. And when Kamailio starts, it just executes virtual machine and it runs constantly. And this gives you even more benefits, to be honest, because you can do persistent connections via the KEMI. And persistent connections means that you don't need to reconnect each time, spend your time on connecting. You can reuse particular connector descriptor to constantly connect to particular service. And here is an example where you can, for example, send to some external service update via the WebSocket if your HTable variable just expired. In really easy way, like that's like 5 strings, not 5, 10. But still, and you can see that this works perfectly. It's reusing connector, and you don't need a lot to do with that. The next example, it's a little bit big, larger than screen, but I'll try to. Yeah. So what it does, this is actually quite useful one, because of here I use DNS to get IP address of the media server. And this have been used in a Kubernetes infrastructure. So you basically use here custom dispatcher to get IPs of the machines you can then use to deliver the traffic. And this one you can see can be tested quite easily because of here I use abstraction of the main functionality from the KEMI and calling Lua just in the wrappers, which you can trust. You don't need even do mocks. And this is pretty good way to make your life easier, because if you can just run usual unit tests against your code and do not have this huge headache with KEMI and mocking around it. Yeah. And even more, here, you actually can extend your functionality of existing modules by using KEMI. So this example extends Kafka connector. So Victor yesterday was saying quite a lot regarding the doing DMQ and distribute messages across the connections. So not all modules support consumers, and for example, Kafka doesn't. And here, how you can easily and cheaply deliver consumer to your code, to your configuration without dealing with updating modules, sending it to the mainstream, waiting reviews, and just deliver everything quite fast and quite nicely to your configuration. Even though you still don't need to have full configuration written in KEMI. You can use this just as extension via Lua run or whatever you want. So, basically, coming back to the first question, KEMI or not KEMI? Yes. That's it from me. Thank you for your attention.
Thank you, Iurii. So to add that to it, yeah, the typo, we cannot blame Kamailio. It's first or second grade teacher that taught us how to write. So that's a good joke. But actually, we have some tools also in Kamailio that it's scanning the code and then it creates for Lua check. It's creating the file for it, and then you can run it and detects all the function exported by Kamailio.
Great.
So you can use Lua check with that generated file. It's in MISC tools or somewhere. And yeah, you can make it in your like restart script or whatever to look at it. You need to generate a Lua check file once for your release, and that's it. And then sometimes also Lua compiler can detect some Lua C. But yeah, then with the parameters and the meaning of the parameters, we have extra checks with some function, not all functions. Yeah. But yeah, always it's a trade-off between flexibility, more feature and so on, and you know, domain-specific language that you can tune it, but then you have the overhead of keep adding that people want new string-related function or new extensions like connect to Kafka or, and that, as you said, can be done easily on this one. But yeah, there is a trade-off. One quick question, and it's also on Python from Tori. So, well, yeah. Okay. So who wanted? Yep.
I just wanted to hi. My name's Els. So I just wanted to comment the same thing. So if you just lint your code, it will actually discover both of those two issues.
Great.
And one more thing maybe to mention, because I actually expected this from you to actually mention here. If you are using Lua, you can actually deploy Lua in bytecode, right?
Yes.
So it's not readable by someone, right?
Yeah, that's true.
And it's like basic obfuscation. It's not real obfuscation, but on the first level, it can just, remove potential users. I don't know who is on that system to actually see what's happening there.
For sure.
But, advice, lint your code locally or on CI. On CI better. And
sure.
That's from my side.
Okay, so yeah, and the question is yes, answer is yes, as you said. Then the break is just to start and just to give a beer jerk quickly. Yeah. Thank you, Iurii, first. Thank you.
Thank you. Hello, everyone. So, VCONs, turning your SIP calls into structured, auditable conversational records. So yeah, I'm Dan Jenkins. A little bit about me. I've taken this all the way down. I recently became a IETF editor on the web spec. Hopefully that's going to be kind of final draft in the next week or two, which is quite exciting. I run a company called Nimble Ape. Oh, that didn't turn out very well, did it? There's an ape there, it's black. So yeah, Nimble Ape, we do real-time consulting in the UK. Also run a company called Everycast Labs, and got a couple of products there. The main one that we'll talk about today is VCON.store. I'll barely talk about it. It's just a way of showing you what a VCON is. And then yeah, VCON.store. I first started talking about VCON.store a year ago at OpenSIP Summit, and we're now a year later and we're finally actually launching it. But very quickly before we get going, ComCon. So I run a conference, usually in the UK, around real-time communication. This year, we're co-hosted with Sipgate, which means it's in Dusseldorf, 9th to the 11th of June. Very cheap ticket, cheap hotels at the moment, etc. 1 day of hacking. That's not a hackathon, that's just, get to sit down and actually just, play about with some code with fellow people that kind of get what you're doing. And then 2 days of talks, full of talks. And speakers are being announced as we speak. If you want to come, 2026.comcon.xyz. And we are looking for more sponsors. So if you're interested in sponsoring, then come talk to me. Sponsorship is, again, fairly cheap. Anyway, on to this. VCONs. So what is a VCON? How many people in the room have heard of VCONs? Oh, that's actually a very small number. Out of those people that put up their hands, how many of you actually understand what a VCON is? I'd probably say that's like an 80% drop-off rate. So, what is a VCON? Conversations, and that's the gist of it. It's in the name. It's a VCON, conversation, virtual conversation. So we have an awful lot of conversations. They might be voice, they might be video, they might be chat, they might be SMS, they might be WhatsApp, they might be email. They're all conversations, and they're all kind of siloed into their own independent places. So you have CDRs, you have WhatsApp conversations, SMS that you can't get from anywhere else, etc. Email. Email's not siloed, but you get the idea. We've got all of these separate conversations all happening. They might all be happening with a customer, and you need something to kind of glue all those conversations together. There's no common format, there's no common way to share that conversation with other people, and there's no common way to go and sign that conversation, that whole conversation, with another to sign it. And then there's no way to actually go and commonly redact information so that when you share that conversation with someone else, they don't get certain bits of that information. It's all kind of custom up until VCONs. So yeah, up until now, that's been how things are done. But now we have VCONs, virtualized conversations. Thomas, the guy that kind of thought about the whole thing and pushed it all the way through the IETF, he says think about them as vCards, but for conversations. It's just a container. It's just like, a container around audio, a container around video. So, but it's for everything that happened within that conversation. It's all standardized, it's all portable, it's all verifiable, and it's all properly standardized in the IETF. So it's charted. The IETF working group is chartered, it's active, and they're actively putting stuff out. It's not just sitting there. There's 3 drafts within that working group, and so there's the overview, there's the core, and then there's the primer for the privacy. So let's open up the core bit. It's just JSON. And then you go, well, why is there a whole working group around, making a JSON document? It's a very good question, but it actually takes an awful lot to kind of come up with the right structure that is actually going to work flexibly across all of these different mediums, right? So what is part of a VCON? What's the bits that actually have to be there? So there's a UUID, there's created at, there's updated at, there's a subject that tells you underlyingly what is this conversation, and then there's 4 arrays. So there's parties, there's dialogue, there's analysis, and attachments. And that's it. So like you can actually imagine it like it's relatively small. There's like 4 or 5 main keys, and then there's an array, there's 4 arrays of objects, and that's it. Sure, it gets expanded out the more you put into a VCON, but at the core of it, there's not a lot there. So what are those arrays? Parties. Who took part in the call? So you can put in, telephone numbers, you can put in SIP URIs, email addresses, names, validations that went into it. Then you've got your observer and your callee and your observer within that. You can say, right, this person was the caller, this person was the callee. Then you've got your dialogue. Dialogue means something very different to, say, in SIP world. What was actually said? And yes, it is very different to SIP. Dialogue is what was said and where. So you've got your recordings, you've got your text, and you've got transfer information, whether or not it was incomplete, whether or not the attachment, the reference that you're referencing was in line, etc. Or whether or not it's by reference. And if it's by reference, so I've got a call recording and I want to say, this is what was said during this call. Here's a call recording, and you reference it with a URL. Well, that URL can now change, right? And it's no longer, self-contained within this VCON. But you then, hash it and go, well, this was the hash when I created the VCON of this audio recording. So that later on, when you come back to it, you can say, this audio recording hasn't changed, so I can trust that the fact that this audio recording is exactly the same. So that's dialogues. Then we move on to analysis. So what did we learn from the recording, the transcription? So your dialogue has your actual recordings, and then you've got your transcripts within analysis. So you've got your transcripts, you've got translations, you've got sentiment, you've got summaries, anything that kind of gets attached to the VCON and goes, this is what happened, but in a more accessible manner. You can put other stuff in there as well, vendor, product, schema, etc. And then this is actually where you go and put in your attachments. It could be anything. Screenshot, a PDF, a consent form, anything at all. And that can be inline or it can be a reference. Finally, there's 3 forms of a VCON. Yes, I'm going to get to an actual, this is what a VCON looks like in a minute. So there's 3 forms of a VCON. Unsigned, and this is what you'll all start with, probably. This is, I've created a JSON document, and that's the end of it. But unsigned VCONs aren't actually very helpful in the grand scheme of things, and I'll get onto that in a minute. Then you can have signed VCONs, and then you can have encrypted VCONs as well. You sign for integrity, you encrypt for confidentiality. Ideally, we should be doing both, right? But conversations evolve. Once we've started a conversation, so we've got a VCON, we've created a VCON, right? But I come back to you later on via my WhatsApp message, and suddenly the conversation has evolved. Well, does that mean that I go and create a new VCON? Does that mean I patch my other VCON that happened earlier, but the one that happened earlier is already signed? You can amend VCONs. You can add analysis. You can add extra stuff into it. But you keep a reference to the original one. Keep a reference and say, this was the original one, and this is the signing that was with it. This is our new amendment, and this is signed. And you can keep amending it, but at the same time, you sign, so that you know that what was in the original one was actually in the original one. And then you can create redacted VCONs as well. So this is stripping personal information, etc. But then you create a new VCON with the stripped information and you link to the original one. So this is great for long-term archiving. You can say, well, within the VCON itself, you can say, I want this to live unredacted for 30 days, but after 30 days, I want my phone number redacted out of it because you don't need it. You can keep the record of the call and you can keep all the sentiment and everything else that was within it, but you need to remove my personal information from it. And this is part of consent. So that's long-term archiving. So you get nested signatures and renewable certificates, extensions, compatibility. Yeah, it's all within the spec. I'm kind of going over things quite quickly because I've got 227 slides. You'll be glad to know I'm 102 all the way through so far, right? So we're doing good. So privacy, what I was just kind of getting onto just a second ago. It's all about consent. Conversations are personal, right? A VCON can hold everything. A VCON can hold all of your information about that conversation that you've been having with your mum or with your energy company that you're really unhappy with, right? It could hold anything. And that in itself is a really powerful thing. Before, we had all of this messy data, right? Data everywhere in different formats, and so it was kind of security by obscurity. Obscurity, is that a word? You know what I mean. But now we're suddenly making it easy for AI to come and read these conversations. That's a superpower, and we have to be careful with it. So yeah, it's dangerous. This is where the privacy primer working group comes in. They've got 10 principles: consent, notice, purpose limitation, data minimization, storage limitation, security, individual rights, data integrity, accountability, record keeping, and consent must be freely given. It has to be specific, and it has to be informed, and it has to be revocable. I can't say that word for some reason. And it has to be documented. So you can kind of get a big picture here, right? It's a document, and it has parts of it, but within those parts, you can say, here's a call recording, here's some analysis, here's some transcription, but I want you to redact it after 30 days, and I've only given you consent for training purposes. And suddenly it's within this one JSON document. And it kind of makes a lot of sense. So VCONs can carry that consent within the data, and that's the most important bit. So let's talk about how we actually go and build one with Kamailio. So it's a little bit small, but hopefully you can get the gist of it. We've got a caller calling in from the PSTN, comes into Kamailio, comes into RTPEngine, and then we send it off to a SIP server. In this instance, I'm actually sending it to 11 Labs because they have a nice SIP agent, and it's super easy to just send traffic to them instead of me having to bring up even more demo things that inevitably break. That SIP server then connects to whoever. In our case, we're talking straight to an AI agent. And then during the call, I've got a VCON sidecar that's sitting right next to Kamailio, and it's sitting right next to RTPEngine, and it gets these events from RTPEngine and Kamailio. I think it's not actually getting an event from RTPEngine. It's the way I wanted to do it. It's actually looking at a file that has an open file descriptor, and then it's really janky. Like, don't do it that way. But this is the way that I did it for the demo. So the VCON sidecar in this diagram goes and creates that VCON, and then it chucks it up to something called a conserver, which is just a VCON server. And the spec for that is part of the VCON stuff. And then once you put it in, it gets signed via something called SCIT. I'm not going to talk about SCIT too much. It's just a way of signing the data. And that, you can see, runs a create and a patch. So we actually have the call going, and then when the call ends, we actually create the VCON immediately. And then we go in, once the recording's done, and once we've got transcription, we go and patch that VCON. So yeah, Kamailio, RTPEngine, we record, oh, why did that go backwards? We record each leg so that we get independent audio. We get the caller, callee legs completely separately as audio. And then we've got our sidecar listening for the right events. Call start, call end, gets the data out of RTPEngine when the file has finished recording, and then goes and creates the VCON. It then attaches the consent because we know that they were played back this call may be recorded for training purposes. And so it's able to attach that consent to the VCON, and then it uploads the recordings, patches in the transcripts, so you can go off to your AI provider to get your transcript. You patch it into the original VCON as an addition, and then it all goes through the conserver, which is a standard API and it's a standard contract. So you should be able to go and send VCONs to one provider, but also send VCONs to another provider, and it all just work. So it's all logged, and it all goes through Skit. Tamper evident, lifecycle, etc., etc., etc. So let's take a quick look at. I want to change. I want to show you my whole screen. Start mirroring. So, what have we been working on for the past year, on and off? So we created something called vcon.store. I'm not going to try and sell you a vcon store, but it does have a nice free tier so you can go and create vcons, and then you can send them up to us, and we will store them for you. I think that's a key bit that's missing from the whole ecosystem. You can go and make vcons, but what do you go and do with them? Like, I can go make them and I can go store them somewhere, but how do I know that I'm doing it properly? You go and use something like vcon.store. So we can go over to our dashboard and we can see my vcons, and you can see I created some earlier. So we've got this one, and so you can see here, hopefully, is that big enough? You can see that we've got a call. It was 7:10 this morning. I think that's in UTC. It tells you how many parties were in there, how many dialogues happened, how many analysis were added, who the call was from, who it was to. This all sounds like CDRs, right? But then I can go in and I can play.
Hello there. Welcome to Kamailio World.
I can go play those two separate legs because they're attached to the VCON. I can see exactly what was said and when. I can go get an analysis about what happened on the call and whether or not it was a good call or bad call, what was the summary of the call, etc., etc., etc. And then you can see here there are different versions of the VCON. So this was our original VCON, and then I went and amended it with a note. But you can still go in and see this original VCON. I amended it, and then this last one I went in, so we were viewing the amended one, and then I went in and redacted a load of information. And suddenly you can't see what my phone number is because I redacted it. But you can also go say, I went in and manually redacted it. But you can actually go in and say, I want this to redact on this date, and it will go and redact it. So that's vcon.store. It's super simple, super scalable, just works, and that's it. So let's show you one actually being made in real life.
Hello there. Welcome to Kamailio World. I'm Bandit, your personal assistant for the conference.
Who does he sound like? He sounds like Bandit from Bluey, because I tried to make a voice clone of Bluey, of Bandit from Bluey. Who knows Bluey? Who watches Bluey? Bluey's like a phenomenon. Everyone in this room needs to be like, hello. Anyway, so hi Bandit. Can you tell me about Dan Jenkins's talk at Kamailio World?
Absolutely. It's great to meet another Bluey fan. So Dan Jenkins, the CEO of Nimble Ape from the UK, is giving a talk on Friday, May 8th from 11 o'clock to 11:30. His session is titled VCONs, turning your SIP call.
Yes, okay. Would it impress you to know that you are in a VCON right now?
Oh, that's quite a thought. It certainly
Anyway, so you get the idea, right? That's just talking to 11 Labs SIP endpoint, and literally I told it I want a voice agent. It gave me a prompt. I changed the voice, and I changed. I think the name of the agent was Kit, and I changed it from Kit to Bandit, and that was it. Like this is what we're kind of living in right now. So you can see the original one has been made, and I can click into that, and we can see our consents. You can see I was working on this literally an hour ago, and I seem to have messed up my formatting. But you can see the consent. Has it got consent? What kind of consent has it got? When does that consent end, right? And this is all within the VCON. It says no dialogues because the call only just ended. Attachments. So it knows about, it knows that there will be two attachments, and it has these bits of data against them. If I refresh, hopefully other stuff has arrived. And you can see, so I've now got my dialogues, now got my call recordings, and you can see what happened in them, my analysis, etc. And then you can see the activity log within that VCON of it being patched. But there's only one VCON. So I can go in and redact it, and I can say, no, I want to redact everything from it. So then it goes and makes my redacted version. And then I can share this redacted version with a third party, right? I still have the original VCON. I can share this VCON, this redacted VCON with another party. And because it's all unique, if information got leaked from it, you could tell who it came from, who leaked the information. And then you can see the versions within it. So that's vcon.store, that's VCONs. Let's go back to my slides, because I'm semi-running out of time. Extend display. So, I can't see. There we go. So, demo, yeah. So that was Kamailio with RTPEngine, sidecar on the side of them, creating the VCON and then uploading it to a VCON conserver. It doesn't matter that it's vcon.store. I'd love for you to all go make accounts on vcon.store and make a subscription, but you don't have to. It's all part of the spec. So yes, what is vcon.store? It is a home for your VCONs, storage, search, indexing, all the difficult problems of VCONs, going in and actually like indexing the important parts of a VCON so you can go and search for it. Auditing. I've had numerous people come up to me and say, why do I care about VCONs? I think I'll come on to it later, but just in case I've forgotten to, auditing is the most important part of a VCON. It's compliance. It's being able to go to a government or whoever and say, this is what happened to the call, this is what was recorded, we have stored it in this way, and there is an auditable record all the way through. And on this date, we redacted it and all of that. On this date, we completely deleted it. A VCON would still exist, but there would be nothing in it, right? So, yeah, auditing is VCON's superpower, is my personal opinion. vcon.store is conserver compatible, and then you can bring in your existing stuff. It's got a nice clean API, it's got a nice dashboard, it's got webhooks that tell you about things when they happen. Everything gets signed using Skit, and it's privacy first and consent built in, etc. They're UK based, but if you were in the US, then your data gets stored in the US and it's completely independent. So your data gets stored completely separately to everyone else's data. So there's no way of accessing someone else's data set. GDPR friendly, we've launched, etc. at Kamailio World. After a year, I'm really happy that we finally did it. So yeah, why does it matter, right? Storing conversations isn't new. I said this earlier. CDRs, we've had CDRs from day one. But CDRs really have been misused. CDRs are very much designed for, I need to bill my customer for this call that started at this time, ended at this time, and it was between these two numbers, which means it cost this much. That's what CDRs should kind of point you towards, right? They're not records of conversations. So yeah, recordings since day one, but that part is all solved. What hasn't been solved is proving you had that consent. Oh, I did get to it. So auditable, but it's also proving that you had the consent to be able to do the thing in the first place. Proving that you played them a recording that said calls may be recorded. Proving how long you can keep it for. Proving how much you redacted, etc., etc. Proving everything. So that is the point of VCONs. It is consent, it is privacy, it is having a meaningful way of being able to say, here is this record. So that was the gap, and that's what VCONs have filled. Auditability, compliance, portability. Portability less so. Until other people get on board, and you can say, send a VCON to DeepGram and go, here's my VCON, go and transcribe my VCON. Until other people in the field start accepting VCONs, portability doesn't mean that much. The other two are the key things for me, auditability and compliance. But they're not just saving conversations, they're saving trustworthy conversations. You can actually trust the data. It's not messy data anymore. It's not data that could just be changed. Conversations are the data. Data needs structure. Data needs trust. And AI loves structured data, which means you absolutely need all the compliance and all the auditability and all of the signing so that you know what has happened when. Yeah, VCONs give you all of that. So what could you go and do today? Read the drafts, go interact with the working group, go build a VCON, chuck it up into vcon.store, have a look at that VCON, how it worked, etc. And then don't forget to come to ComCon. ComCon is on sale right now, 2026.comcon.xyz. I think they're £140 at the moment because early bird has ended. It's literally in a month's time. And very quickly, one more thing. Free World Dial-Up. Who in the room knows about Free World Dial-Up? More people in this room know about Free World Dial-Up than VCONs. That's cool. My friend Jeff, he has brought Free World Dial-Up back. You can go to fwdialup.com. You can sign up. You can get a number on Free World Dial-Up. Yeah, it's back. Doesn't mean much to me because I'm younger, let's just say. But it's a cool thing. The cool thing about Free World Dial-Up, after a call has been made, you can set a webhook, and then at the end of the call, you get a VCON to tell you what happened in that call, which is pretty cool. It's not quite working, which is why I haven't demoed it. When you go to save a webhook URL, it says failed to save. And I was like, but I really want it for my demo, because that would have been cool. But yeah, Free World Dial-Up is back. But the thing that was missing from it, I was talking to James and David yesterday. They were like, oh, we're on it as well. Who else is on it? I was like, I don't know. They were like, is there a directory? I was like, not that I know of. There used to be one. You used to call 411 on Free World Dial-Up and it would give you a directory. Well, with the power of AI, I went and made fwd411.com yesterday. And you can go and sign up for Free World Dial-Up. You can put in your thing in fwd411 and other people can see who you are and ring you. David rang me last night. He was like, hello. I was like, hello. It works. Why are we so surprised that VoIP works? But it does. So go add yours. Voice is back. For me, not a lot was happening with voice for a number of years. Voice is definitely back. And that's not necessarily the fact that nothing was happening technically, but external people, the public's interest in voice was definitely dying But now they can call a phone number and they can talk to an AI. And suddenly it's interesting again. So voice is back. And that's me. Thank you very much.
Thank you. Thank you, Dan. Okay, so 2 quick questions. Tori, it's here.
Was I bang on time? I'm pretty impressed with myself.
So yeah, I have a question about redaction. Since the VCON is essentially a linked list of diffs, if you say you want to delete something, if you're going to be secure about that, you would have to delete the VCON that introduced the data too. But if you delete that VCON, then you can delete other information that was in that VCON that isn't supposed to be redacted. So how do you go about dealing with that?
That is a complex question. Short answer is, you can go. You're in control of it. So you can create your VCONs and you create your amendments, and then you go and redact it. But the original one still has stuff within it. Yes, you basically kind of delete the previous VCON is the answer. You can basically say, right, we're done now, and so you end up deleting it completely in an untraceable way, so that you only end up left with the VCON. But the record that the VCON existed remains. You just delete everything within it. Does that make sense?
Oh, so you can modify.
You can modify a VCON all the way through, but you have to record, you have to audit all the way through, so that you know what has been changed all the way through. You don't know what the state of it was necessarily at the beginning because you've amended the VCON, but there's an audit trail all the way through. But yeah, at the end of it, you'll go, I want to destroy this VCON, but you don't actually destroy it. You keep it as a record, but you remove everything from within it.
Okay. So, thank you, Dan. Dan, really
thank you
shedding light on this new technology that could help us.
So today I wanted to introduce a little bit the Signalwire for what concerns the developer APIs. And so I'll go through the architecture very high level. And I will focus a little bit more on the developer API interfaces, and in particular on SWML, which is the programmable language that you can use to build your application. And I will do a demo, which seems a little dangerous, maybe. We'll see. So as Daniel mentioned, I've been in this industry for some time now. I'm leading a team in Signalwire to improve and expand the developer APIs. And hopefully you will see improvements in that area. Last year, I presented something at very different abstraction level, focused on troubleshooting media negotiation on WebRTC calls. So, as you probably know, Signalwire is built on top of FreeSwitch, which is the media engine and is managing most of the media interaction and processing, including an AI kernel. Kamailio is a key component. It works at the edges. We use also KEMI and Lua, and it is, in fact, very, very cool, and we can do a lot of stuff with it. And coupled with RTPEngine for some cases, Kontron for managing the WebRTC clients, and Epic, we use it internally for troubleshooting. So this morning I saw that finally we got the new release out that probably people was expecting, so please check it out. That's a lot of work that went into this release from the core team and the community. Mostly security and stability. There was a large cleanup of the code, eliminating many modules that were basically not actively maintained, and so to clean up and make it more lightweight. And there was Debian 13 support and other improvements in the platform and tool chain. So the idea that was behind Signalwire, in particular, if you consider maybe some more critical cases like the very popular currently for AI, was that eventually, once you build your application and you're assembling different stacks from different providers, you're going to have most probably maybe some advantages, some practical advantages, but in terms of flexibility, but you will encounter most probably some problems in terms of state fragmentation, different types of errors, dashboards to integrate, and potentially, and this can be discussed and measured, a final impact on the latency on responses, depending on the scenario. The idea behind Signalwire that had the AI modules added obviously more recently was that everything is native, and so eventually everything that is also very key specific to AI interaction, like the barging and the turn taking, is not delegated outside to an LLM, but it's managed directly inside FreeSwitch, which makes it much more efficient, and also includes also payments that were added recently. So if you imagine the media engine based on FreeSwitch and the other components, and that it's globally distributed on multiple regions, and then the different developer interfaces, there are 10 different SDKs, or better, SDK in 10 different languages. There is a declarative programming language, Swiml, a REST API, webhooks for getting events, but it's just one way of getting events, and what's called the call fabric addressing, which is just a way of abstracting resources inside the Signalwire platform, giving them an address that doesn't have a specific transport or type associated to it. It's more like the Signalwire's responsibility to resolve that address and adapt it to whatever it's meaning in that specific moment. It could be a SIP endpoint, a WebRTC endpoint, or even something different, like it could just be the address of a script that needs to be executed. And so the control plane has the main role of interfacing these two worlds, and in particular have a good ownership of the state so that it's consistent across different use cases. So in terms of interfaces, of course there's signaling, there's the REST API over HTTPS, there's the so-called relay protocol, which uses server-side SDKs that connect over WebSocket, and then they have a bidirectional communication with the system. They can send command, receive states, updates in real time, or even commands from the platform. The WebRTC client over WebSocket again with a proprietary protocol that anyway is abstracted by the SDK, and of course SIP over different transport. For media, obviously RTP and SRTP, and DTLS SRTP for WebRTC, and when needed, there's NAT traversal with turn. And in addition to this, there's also the ability to just connect raw, to connect WebSocket and just make raw audio flow in both directions. And this is also a way how somebody could bring their own AI, because once they have the ability to connect a stream to their whatever implementation of AI they have, then the interaction with the system is just connecting one WebSocket to it and exchange audio. Then events are either provided through webhooks that can be also signed, or they can just be real-time events over the WebSocket when connected. So the REST API provides a way to basically manage all the resources. It's what you have in the dashboard. It's also exposed in the API. So you can create the resources. You can exercise the scripts. We recently added a way by which, with a REST API request, you can just run a script without having any actual call active. So whatever the script will do, which may be even creating a call or calling another script, happens through the REST API without the need for you to call from PSTN or from SIP. And there is a reference to the REST APIs, which are quite large. So you can do the usual things that you can imagine: calling, queuing, recordings, conferences. There's also video, of course. Then you can manage your own numbers. You can set up your own SIP gateways, write and manage your programmable scripts and AI agents. So these are the ways you interact with the system and you build your service. There's the SWML, which we'll see a couple of examples of later, which is just declarative language. You can write it in JSON or YAML. You can have static scripts or dynamic. So dynamic would be you get a request for an incoming call from Signalwire, and your business logics just generate on the fly the SWML script with the programmable logic depending on all the metadata that you receive. You can have a server-side SDK, which we call the relay SDK. It just connects over WebSocket and exchanges commands and events in real time. So again, say there is an inbound call, you get an event to the client using the SDK, and then whatever logic is needed, depending on the from number and the time of the day, and whatever you can imagine. There is a WebRTC SDK, which, by the way, there will be a new version, which is now almost ready, with many improvements. There is already one version out, but there will be a much better version soon for managing WebRTC calls. And then this is more like, the call fabric is more like a concept of abstracting resources through generic addresses. And of course, if needed, you can use the AI agents that are available. Which are, by the way, completely you can completely define them with SWML. So it's just, you can use SWML to program your, your AI agent. So this is an example, super simple. You just define what needs to happen. Again, the SWML script could be static or dynamic. You decide. You can serve it, or we can also serve it from our platform. There are more than 50 methods. You can imagine what they are. It's like imagining your dial plan just defined in this sort of declarative way. And there's some documentation for who wants to go directly there. So beyond just calls, there are very interesting features. Of course, conferencing and queuing, which is basic, which are the basic for the many contact center scenarios. There's the AI method for defining AI agents, and other interesting things like live transcriptions, which is quite cool. And as mentioned, we also have payments that can just be processed directly on the system. And a little bit of controlling the calls, or in general, the processing branching, like with conditionals and managing the state of the system with variables and conditional actions. Like, for example, typical if-then-else system, this is simplified, and it's YAML, but you get a call in, or you exercise the, in this case, no, you get a call in, you answer, you get the time of the day, you make a decision, and then you behave differently depending on the time. You just say something, and then you connect to, you put the caller in a queue, or you record a message. Also, something powerful, you can perform requests directly from the scripts. So like in this case, you provide a URL with a body that is filled with metadata from the call itself. You perform the request, and then based on the result, you can have conditional behavior. You can make a decision depending on the HTTP request response. And then it's, as you can imagine, so you can play something, you can connect to a SIP endpoint, or move to a queue, or or a default behavior, which is quite powerful. And again, this can be either static or can be dynamic. So it's up to the developer to decide. Also, maybe interesting to see prompts. So very simple way to gather digits from the call that's connected, and again, conditional behavior depending on the real-time input. So that was SWML, which is the declarative way of defining the programming language. Then on the server side, you can have you can use the Relay SDK. Again, it connects through the WebSocket, bidirectional communication, and you can use the same methods. It's just whatever technology or programming language you're using on your server side, you will have it available from the SDKs. And again, you will get real-time events directly pushed to the WebSocket you are connected to. Call Fabric, as I mentioned, I mentioned this because maybe it's a concept that is worth explaining in case it's in the some parts of the documentation. It's just a way of abstracting the resources. So as a developer, you don't need to worry whether something is a SIP endpoint or a WebRTC endpoint, or say an AI agent, or even a script. You can associate a generic address to the resource, and then that address can be used in different parts of the system. It could be inside a script. There could be a script that connects to another script. So it becomes very, very powerful for building whatever you need to build. Briefly, even if it's not the core of this presentation, there's you can define your own AI agents. The promise that the system is doing is that due to the native support for Bargin echo management and the turn taking, that happens directly in FreeSwitch and it's not delegated outside. The aim is to get a much better overall latency. And so to prove it and to share the results, Tony recently open sourced this code for checking the latency. So you can just put there the recordings and it does an analysis and you can do comparisons about different implementations. So all these, you can see how you can compose all these layers and all these different ways of interacting with the system, depending on whatever you need to do. With SWML, you can define your, let's call them advanced dial plans. You can manage inbound IVRs and escalate to an AI agent if needed. With Relay, you can have your programmable contact centers. If you are, which probably most of you are, if you already have a SIP platform, you can just connect it to Signalwire. You can send the calls in, addressed to specific CPRIs that are associated to SWML script. So you will have your programmable logic executed on the fly when you connect. And with the REST API, you can manage from the server side, you can manage your numbers, your addresses, you can inject your programmable scripts and define your addresses. And the idea is that all these can be done very quickly. It doesn't need a big interconnection process for getting there, thanks mainly to the REST APIs. So in terms of demo, it's going to be something very trivial. I'll just expose a SWML script from my laptop, and then I'll call a SIP endpoint associated to it, and I will have it executed, and then I'll change it in real time and see that that it's just changed, and I can use with the new logic. It's going to be super simple, just some Python script that generates JSON. So let's see. Okay, so say I have my Python. So this is the Python code. You can just run it. I have ngrok already running here. Just let me test it quickly. Okay, which is working. And then I have in another tab, I have we will see a little bit of metadata from the ngrok debugging interface. And this is where I'll define the behavior for my application in the dashboard. This can be done programmatically, just it's easier now for this demo to do it manually. And this is where I set up the external SWML script that will be called when that SIP domain is actually called. So let's see if it works and if you can hear it. No. Okay, so maybe this is a candidate for dangerous demos. Because I got banned yesterday. So the source IP that I was using was banned by Kamailio because I made too many authentication failures. So let me see if I can solve it in real time. Otherwise, I don't think so, though. Let me see. This is running. This is running. This is working. 5899. No. Okay. Oh, I see the error. I should copy this one. And Grok changed my. Yes. So I save it, I change it in real time. I call again.
Kamailio World 2026, Javax. You are connected to a Python handler running on the laptop.
Right. So this was a very dry and a message automatically responded from the script. Then if I go again in the script, say I edit it, and I do a minimalistic AI agent. So this is all it takes to have a default AI agent available. It's I don't know if it's very visible, but let's say it's so it's the AI method and then the super simple prompt. You can imagine you can define whatever complex behavior you want. Plus, there are all the options that you can set, like the timeout for waiting for voice activity detection, and all the other settings. So, assuming there are no syntax error, I change it. I run it. Just let me double check. Okay, and then I call again.
Hello, Giacomo. How can I assist you today?
And this is the AI agent connected already. And that's all I wanted to show. Then if I go back to the presentation, just for the takeaway, so I mentioned what's behind the media engine, globally distributed free switch with AI kernel inside and Kamailio, plus the control plane that exposes interfaces for development, aggregation of state and policy and protocol normalization in one single place, and a bunch of SDKs available for the developers. Just mentioning KluCon that will be in August 10 to 14 this year. So everybody here is invited. And that's all from me.
Okay, thank you. Giacomo, I have a first question here.
Thank you for the session. So most of the existing free switch-based contact centers has already evolved into a AI-driven workflows, right? So they internally creates a graph representation of the flow, and it creates a JSON document, and that gets executed in the free switch as an ESL application. What prompted Signalwire to create something like Swiml, which the existing UI-driven systems are not able to solve, or what operational difficulties that prompted you to create something like Swiml?
Yeah, I think mainly I would say the ability to abstract and have something defined in a way with a syntax that is not really connected to the internals of free switch. So it's in theory users, and in fact it also happens, there are users of Signalwire that have no experience with FreeSwitch, and that was the main objective. And of course, I've shown just very rudimentary scripts where you can imagine for each of them, for each method, you can define your webhook URLs. So then you get the state in a specific format, and you can do whatever you want to do with it. Something that I wanted to show very quickly here, the ngrok debugging tool. So this is the metadata that was received by my server when I got the call. And so you can see all this metadata is available through variables to the script, and then can be used to execute. It's
okay.
Not related to your question, but I remembered.
It's Surrender. Quick question, hopefully, because we're a bit late.
Yeah. So thanks for the demo, and I really love the way it's being creating AI agent and connecting with voice. So I just want to know, does it support knowledge base or integration with VectorDB? Probably like I can integrate with multiple tools here with SWML.
Okay, I'm not sure I got the question, but did you ask about integrating with other LLMs?
Okay, I'm asking about integrating with the knowledge base, RAG.
Ah.
Okay. Do you support with current SWML with integration with like particular knowledge base or particular VectorDB? So suppose like there is a prompt is written, and once I detect the intent, I want to like take certain actions using tools, or might be using like my knowledge base stuff.
I'm not sure. I would need to. Maybe we can discuss later. I'm not sure I got the question. Sorry.
Okay. Thank you, Giacomo. I really appreciated your update. And I saw.
Everybody, thanks for being here. We know it's 15 minutes before lunch, so everybody just come up, stand up, shake your arms, get a little bit of freaky. And yes, we will present some code snippets, so a few of yours sent them to us in the last days, and the challenge is, you have to crack it. We did it last year, it was fun. And it's a little bit complicated because some snippets are quite long, so they don't fit on the screen, so I have to sneeze them a little bit. So that's a double challenge today. So there's a script on the screen. You have 2 minutes. We will play a little bit music in the background. If you crack it, you will win a fantastic T-shirt we make only for this conference. Andreas is presenting it. And we have one more rule. Last year there was a guy making pictures of the script and just asking the LLM what is the purpose of the script. So that works, so it's not allowed. So if we see people doing pics, you are out and you have to go to the lunch at the first person. Yeah, so we can start. I have music here. Yes, it's okay. We start with an example. It's from my colleagues, and it's the same last year. So if you remember, you can maybe crack it. But there's no prize yet. So normally we make it half a minute or something like that.
So you can raise the hand immediately. You don't have to wait for 2 minutes.
Yeah, if you know it, just raise your hand.
What this script does, what this snippet of Kamailio config does.
Sorry. Yes, it's kind of. So it's basically username contains invalid characters. So
congratulations, yeah. No prize for you.
No prize.
It was the demo to show.
So now we're starting. Actually, we haven't checked the code or the answer from you sent us. So we trust you. So we will also be surprised what the snippets are for. So let's start. Ihor, where are you? Here. So it's your challenge.
Santiago?
Okay, I didn't get the main details, but it looks like a beacon encoded into an XML format. Okay, so the road, yeah. no, that's the idea. I was trying to get the
It's definitely
words, okay?
XML.
It's, a beacon presented on an XML format, and it's just trying to modify it or to write it.
Yes, but why?
Why? It's the question. Why is modifying? Because we know it's XML there is. You have to give the solution in a few words. Otherwise, okay, sorry, next one. So you have to come with conclusion, not okay. Okay, we have there.
Maybe to send Siprec. No.
No. Okay, not Siprec. Anyone else? We have Tori again for running for the prize now. Tori and then behind.
I believe this is the body of a notify for the dialog event package, possibly for informing the state during a call transfer.
Not yet.
Kinda this direction, but why?
I believe this is about BLF, BZLM field, state notification.
Yes, but it is about dialogues, but what is actually happening there? Why?
It's stripping from the XML body everything except those fields.
Basically, yes. So, yeah. So it's actually sort of the privacy. So
we should make the rule. You have to give the answer in less than 10 words or maximum 10 words, like the conclusion or something. What is the prize for?
Excel.
And I will give a beer jug to the one that I consider at the end the most interesting, because I want to watch all of them. I kind of forwarded some of them, but I haven't checked it. So
next one, Mario, where are you? Okay, come to you with a mic so that you can answer the question. Do we have a timer? We need a timer. Okay, let's go.
This is at 2 a.m. after the wine last evening. Anyone? So looks like he nailed it down for everyone.
Any guess? 1 minute left.
Anyone who hands up? No? Nothing. You want?
Manually implementing the loose route function.
Is it manual implementing the lose route function?
Yes, but when? Yes.
Yes, but okay.
Partially.
When? There is also the question when. Okay, Iurii. So it was. If you are the size huge, you get an extra small.
It seems like it's hides via header, just to, so it re-implements lose route, but it's also hides via header.
Via header? No, I don't think so. No.
No.
Okay. Come on, guys, you have half of T-shirt already. Okay, time is up. So
we have a winner.
A winner.
So here's the answer.
He did a submission last night, 2 a.m. after party. So I'm not sure if he knows exactly. So the answer is, it checks if the NAT is source IP, and if so, performs loops routing manually, only for NAT case. So you missed the NAT condition.
It's in production? Yes, it's running. No, okay. Okay, Hugo. Beside, yes, it's your challenge. That's correct. Here, come on.
Come on, guys, this is easy. You should be able. So I would say, like, the question would be, what's the result of this? The value at the end.
Is it meant for proxy authentication to count the N1s?
So it's proxy authentication or what? Can you say it again?
Is it for proxy authentication?
Okay, yes, we have a winner then. Yeah, it's computing the, HA1, the hash password, but with this HA1 256.
Congratulations.
So implementing digest authentication more or less with config operation, not using the module.
Hugo, what's your size? Large. Okay, are you ready for the next one? Who needs some sweets? Some sugar? Okay, let's go.
Hell yes. Whoa. Whoa. Again, 2 a.m. I can say it. Sorry.
Is it analyzing the via headers, trying to check to see if there is a loop?
Yeah. Okay, that's correct.
Story. Spot on.
Which size? Okay, next one. I think it's only 3 of you, or then another. Okay, Andreas. Are you ready? I think last year there was also another a nice one from you. So.
Okay, Andreas. Now, what's doing this one?
The Huma guy is looking.
Okay, we have here a guess or attempt to answer.
Attempt to answer. It's just adding the source and destination to this Happify server. Right?
Okay, not yet. Okay, Ihor. Okay.
Is it sort of intermediate SIP-dump server, means that is relaying to the other SIP-dump, so and restoring the information of the original?
Not ready. There is Iurii in the back. Close. You are closer.
Well, if the source IP address doesn't equal destination IP address, it forms proper URI for the source and destination IP addresses and calls SIP trace message. SIP trace message, as far as I remember, sends SIP dump buffer and puts proper IP addresses to the particular server.
Happy with the answer?
Addresses.
Okay, good. Iurii. So actually, it's the answer to what Tori asked. More or less about that. Okay.
Next one.
Doing
yeah,
good.
leverage the SIP dump and doing before TLS. Bruno? Yeah.
Okay. Yeah, AVPs, AVPs.
Looks like a good challenge for you. So any guess?
Ihor?
Oh, they're in front.
Okay. It was a race.
Maybe setting debug level based on the method and some values in the hash table.
Not yet complete. Okay, don't say it. Then Ihor. We have to. What? This is good. Okay.
Okay, great. Sweet.
Okay, so.
T-shirt size? Okay, next one. Hikmet, where are you?
Hikmet, it's there. Okay. Be ready to say if it's correct or not. Oh, okay. A lot of fix. Because at that time was no YAML. Again, Iurii on the far end. Let's see the first attempt to answer.
It seems like it forms custom XML notification for the dialog state update, which I think hides color name and replaces it with some specific color name like direction. No?
Good answer or not? No. Next one.
It's a published method to inform the changes in the presence.
No, okay, not yet there. Close its presence, obviously, but okay.
Is it a custom realization of poor dialog info model? Like just publishing the dialog info due to dialog state? It's like making the publish message as poor dialog info does, but like manually.
Okay, Oriol.
I think it publishes it to a group of users. So there's a group of users, and it publishes a state to its members.
Okay, perfect.
You are close, but the group of missing, publishing to a group. Okay. What's the last one?
Yes, the last one.
Okay,
so we're just in time. Just 1 minute.
Then wait, I'll give 1 jack for someone that proposed to encourage this, and I think Andreas paid attention to the needs of the crowd. And then for a good and sharp answer, we have Tori with the via loop. Clear, no doubts. And thanks also for the Sibrek work, right? Thank you. And before we go to the, we go to the lunch.
See?
This is for you.
Oh, thank you very much.
And for Andreas, because they organize the sessions, of course.
Thank you.
And then one to give away for the other participant. James, you choose one. Yeah. Jonas, qu'est-ce qui no. Jonas? No, Jonas? No? Okay, James. He doesn't want to drink beer. So. Okay, this is not in. Didn't arrive one of the participants that canceled. Pre-Aton? None. Alton is there. Okay. The last one, and yeah, after the lunch, I will bring it to you. After the lunch, you know where it is. We'll have the afternoon session. Then will be dangerous demo. We'll give a phone also during the dangerous demo, and then we'll have a phone also for draw at one of the times.
Okay, very quickly, the Danish demos kick off at 3 p.m. That's 1500. The batting order is number 1, Krunal Patel. Number 2, James Brown. Number 3, Wolfgang with his emergency what's it. Number 4, Anita and Alexander. Number 5, Charles and David. Number 6, Lorenzo. And number 7, if it works, well, even if it doesn't work, it's Dan Jenkins. So 3 p.m., everyone.
So yeah, Sebastian is going to present us about some tough task we have sometimes to debug the audio, the RTP. Thank you, Sebastian. Thank you again, the Pascom team, and the floor is yours.
Okay. Welcome back, everybody. Hope you had a good lunch. And now it's my part to keep your eyes open in this hard first slot after the lunch break. What I'm going to do is I want to take you on a journey through a problem that we encountered this winter and how we finally solved it and what we learned and how we made our product or the life of our customers and co-workers better. So first thing, something about Pascom. My ad blocker got updated. It's from IP tables to NF filter, or NF tables. This is our office in Deggendorf. That's where we are based. And the company was founded in 1997 as an IT consultant company, did mostly network, telephony setup, and what those IT consultants do. And then when the first open source voice over IP products popped up, they thought, let's develop our own voice over IP system. And so in 2006, it was when the first PBX product called Moby Dick was released. Today, we are a fully fledged cloud PBX system, and actually we were one of the first to offer a full solution with our own desktop and mobile apps. And of course, we can automatically configure VoIP phones and do not only calls, but also video and chat with our own clients. We are certified in multiple ways. You see it there on the roll-ups as well. Have this extremely expensive C5 certification, which is good in Germany, so we can have doctors and more for our as customers. And we are a DATEV partner, so we have tax, are good for tax companies as well. Yeah, and before we were we were a bring your own trunk PBX solution, but since 2021 we are a all-in-one solution with our Pascom One product, so you don't need different accounts in with different providers. And of course, there's AI inside as well. A bit about me. I joined Pascom in 2021 and have been here in different colors before, but the last 5 years in red. And have been doing telco, open source telco stuff since 2006. And today I'm more on the DevOps side, so with Jenkins, Ansible, monitoring, and all that stuff. But when it comes to telephony issues or new features, then this ends up on my desk as well. And we have our marketing department as well, and they made these wonderful 25 years of Kamailio cans, and please take them home with you. Take them to your colleagues that can't be here. Take them to your wife or husband, or and we have more. If there's nothing on your table anymore, come to us.
It's not allowed in the fan luggage.
Huh?
It's not allowed in the fan luggage.
Then take it home empty. Okay, disable your ad blocker, and then yeah. How did our problem start? Yeah, there was this one day the DevOps team was playing table soccer and ping pong and whatever we do all day, and customer and suddenly the customer support came in and said, there are too many one-way audio calls that our customers report. And he thought, audio issues. We tried to hide under the soccer table, and waited for it to go away automatically. But it didn't, and we already thought so because we had done something before. We had upgraded our RTPEngine from 10.5 to 13.5. And there are some specials in our setup. We have a containerized setup. The containers doing telephony, they are running with host networking. But we still want to use the kernel module for kernel forwarding. And so we need the kernel module in the host image, but use it from inside the container and stuff. And we had done this already before, but the change from 10.5 to 13.5 brought some changes with it. And mainly, RTPEngine dropped the IP table support. So the solution we had before with enabling the kernel forwarding didn't work anymore. So we had to change, find a different solution and have it based on NFT table to support NF tables now. And for that, we had to switch our networking stack from CNI to Network because CNI doesn't support NF tables. And now we have a solution manually enabling kernel forwarding during the RTPEngine start, but that's just a small detail. And yeah, well, customer support said there are too many one-way audio complaints to be normal. And luckily, RTPEngine has a lot of Prometheus metrics, so we could check those. And you see the yellow graph is the old version and the green one is the new version. The header is actually wrong. That's one-way audio sessions in 1 hour. But you definitely see that there's something different than before. And another graph is the packet errors of the RTPEngine, and this is pretty low usually. And if there are packet errors, then they are mostly only in user space. But now, since the update, we had packet errors in kernel, and that's definitely not normal. So we don't know what to do. So maybe first step is ask Richard if he knows something. So I filed a bug ticket with an extremely great ticket title. I explained a bit what we saw, and you know what you could expect what came back. Okay, Richard couldn't help us right now. So we had to dig in ourselves. Of course, first thing you do is restart. Restart helps, always. And actually, yeah, it did. After the restart, customer complaints were gone, but only for a few days. And it wasn't too often, but the customers always said, yeah, we have to dial twice because on the first attempt we don't hear anything. And yeah, it was just too often to be just something else. Yeah, and the only thing we had for debugging is we were sending or are sending the signaling information to Humor, but nothing related to audio. Well, I can tell you what doesn't help you. Ask your support guys to collect those calls. You'll get tons of examples, And some of them you don't even find in Humor. Some of them are with the wrong timestamp, and you don't know which one of those calls that you find is the one that the customer reported. You will get photographed A4 papers with handwritten examples, and at the end you keep hunting headset problems probably. But you don't know which one of those examples is actually related to to the problem that we were looking for. Okay, then we thought, how can we reproduce it? And for the next slides, I'll probably get a discount after the talk from somebody here in the room. Because luckily, we already had some solution. Yeah, we had set this up, and Sipfront was already placing at a low rate regular calls, and but it was running at the site, and nobody really looked at it, and yeah, but it was there, and that was good, and we already knew from the customer support complaints the parameters, or our calls were affected as well, and so we had in-house complaints about the same problem, and so we knew the parameters. There was no audio from the beginning, and so already short calls would catch it. This helps with the minute calculation with Sipfront, and if we place calls from one party in our network to another party in our network, then we could double the chance of catching some error calls. So we cranked up the volume of call tests. We let it run every 4 minutes during the business hours, yeah, and then just had to wait. And Sipfront comes with some graphs that show you the success rate, and yeah, we knew that there were some hits, and then it actually shows you what the reason is why the call failed, and yeah, those were the two main reasons were those that we already expected. Either caller doesn't have audio, or the callee doesn't have audio, and yeah, I call this slide 50 Shades of Red. And luckily, Sipfront also has Prometheus exporters and an API, and so we could integrate it into our own monitoring solutions, and even write a check for Izinga to know whenever it happens. Okay, we could reproduce it. Now we still didn't know what it was, so we have to isolate it. And yeah, that's basic network Linux admin stuff. Yeah, just use TCP dump ngrep, use the Asterisk debugging, whatever. Yeah, and we have in our setup the Sipfront calls were running through a special PBX, and so we had a dedicated IP that we could grab, could we sniff and capture the packets. And yeah, what we saw there was packets were going fine from one side to the other, and they came back, and so didn't find anything on the network. But is there something that Kamailio can do for us? And while studying the functions, we stumbled upon the RTPEngine query v function. This one, when using this in your Kamailio code, you get a JSON object of everything that RTPEngine knows about this call at that point of time when you call it. And then you can do whatever you want with it. You can log it, or we ended up sending it to Humor. So you can just do it before hanging up the call. And you can, since this is KEMI code, as you see, you can limit it to from URI or the domain or whatever fits you best to not use it for or to just use it for those calls where you need it. Yeah, and then we and since it's KEMI, we could enable this on the fly. So that's the dream of every DevOps hacking something into the production system. And we didn't have to wait for another night and a deployment and a restart of the Kamailio, losing all the TLS sessions and all that stuff. And so, yeah. And what we found there is RTPEngine doesn't see the audio. I mean, we saw on the PCAP traces that the packets actually arrived on the system, but RTPEngine didn't see it. What's wrong there? There's something in between the RTPEngine or the packet arriving and the RTPEngine seeing it, and that's the kernel module. And the kernel module keeps a list in the proc file system with all the ports that it currently has in use. And you can just open it or cat it, and that's what I did. And this is actually a screenshot of the bug ticket that I had still had open with the RTPEngine maintainer. And yeah, what I found there is was something with a really high error rate. In fact, it was so high that Richard didn't believe that this was an actual output, and he thought that there might be a kernel module and RTPEngine version mismatch and stuff. And yeah, but but actually this output that we saw there was from a call that had already ended, and it shouldn't be there anymore. And so we knew that RTPEngine didn't free up our all ports that it had opened in the kernel. So we knew what happened, but we still didn't know when. And there was one option that wasn't possible for us is set log level 7 for the whole RTPEngine and log everything, because that would have made our low-key explode. And then we sat there and studied the docs again and found one undocumented but effective flag. You can actually pass the word debug as a flag to the RTPEngine offer. And what that does is it enables the log level 7 for just this single call. And this proved to be a real game changer for us. And when I say undocumented, Daniel, there's a pull request, 4719. It is documented in RTPEngine docs, but not in Kamailio when using it. And but I just tried it, and it works. And this actually helped us find the solution then. And what the root cause was, when a 200 OK arrives, sometimes the stream is modified, and what RTPEngine then does is it deletes it from the kernel and reinserts it into the kernel module. And sometimes this didn't work, and we got some failed to delete relay stream from kernel messages. And we saw those messages already earlier, but the problem was that this call, the call that caused this misfunction wasn't affected by audio problems because the kernel module still stayed open for this call. And RTPEngine didn't clean it up at the end of the call because it had an error in between when the session was modified. And when the next call came in that wanted to reuse this port, then RTPEngine couldn't kernelize the stream, and that's why they had one-way audio. So this was the actual fix. The unkernelize was replaced by an unkernelize with locking. Yeah. Was it fixed? I'd say so. Customer support was happy again, and yeah. And we were happy again, could go back to play table soccer. So how could these learnings help our customers? The first thing is we could empower our customer support to tell when it's a problem of the devices not sending any audio. And since we have applications and they are mostly working on the Mac or Windows, and they are mostly working with a headset, the headset problems are the most cause of of audio issues that we usually encounter. And previously, our support guys sometimes they started a PCAP capture on the PBX of our customers, and then waited until the problem reoccurred, and then they examined the output, and then they told the customers, "It's your device not sending anything." And now they can do it with just looking into our humor and seeing the RTPEngine logs where it says there are no packets received from the device. And the thing we are currently working on is use those stats that we now have in Humor and make them visible for the customers themselves. So our customers already have a dashboard that where they can see all their calls going in and out of their PBX, and we want to enrich this information with audio-related content. And then our customers won't even need to contact our customer support anymore because they can see it already in there by themselves when their devices have a problem. Yeah, and that was basically it. That was our story from the winter. Painful learning, but got our system got it better. Questions?
That's the difference between 20 years ago with hairs and today without no hairs. Sometimes you face this, but again, with help of other tools from open source or from the, let's say, ecosystem, like now with the SIP front, and getting closer and closer, yeah, you solve it. And thank you for sharing. That's quite useful insights. So now, question, story, okay.
I have actually two questions. The first one is the RTPEngine module already, after RTPEngine delete, has the ability to set stats into a lot of AVPs, but you chose to use the query V. Is the stats you get from the query V at the end of the call have more information that's what's exposed through the AVPs in the module?
Yeah. I mean, we did it because we could actually use this function without restarting Kamailio. And for configuring the
you don't want to change the module
gazillion variables in the mod param of the RTPEngine.
Yes, and the second question, what version of RTPEngine is your fix in?
It was, Richard fixed it in in the master, and then backported into 13 and 12, I think.
Just want to add a few words to it, because there was quite some rolling back and rolling forward involved, so we didn't keep our customers in the rain, of course. And we used that data, the JSON data that we get. First, we pumped it into a database and wanted to find out how many are actually affected. And here the JSON was quite useful together with Postgres in a JSON BigQuery, and that's the reason why this format was for us just better.
Yeah. And if you have it in separate variables, then you have to combine them to some log string or whatever. And
I built a JSON document and put it in CDR.
One question in the far end, Iurii, coming to you. I need to call a Uber. Wait a second.
Yeah, RTPEngine has its own API, so basically which Kamailio use via the module, and you can trigger query from that API for the external, with external software or whatever, by tracking call. Why you decide to go with Kamailio in that case?
Because it's we have a dedicated point when I mean, we do it before the call gets hung up, and I mean, if we did it from outside, we would have to do it like periodically, and those calls are pretty short, and you probably most of the times won't catch them.
Yeah, and you got the context with call ID and everything.
Yeah, and we can correlate it to the call ID and stuff. Yeah.
Okay, so sharp in time like a Swiss watch with the Pascom guys. Thank you.
So today I will walk you through how and why we had to manage to get CDRs from our core network, which is an IMS, as Daniel mentioned, and we run mission critical push-to-talk applications over it to our billing mediation finally. So this talk is without AI, legacy, pure coding stuff, so it's a bit old school. About the agenda, first a few words about Kontron, myself, then about the architecture. Our implementation is based on the RF interface itself, so we basically extended the IMS charging module, which was existing for the RO, the online charging. Few things about how we trigger the RF messages through SIP. Then a few call scenarios where you can also see some samples. Few things about the configuration we do in Kamailio to support this interface. And finally, we also did a built-in RF messaging tool, which we can trigger through CAM command. Okay, Kontron transportation. So I said what we are doing. We are basically doing end-to-end network solutions for mission-critical entities, mainly railways, public transport, or other blue light organizations. And we in Vienna are basically developing the core network. And yeah, that's it, what we are basically doing in our team. And a few words about myself. I'm Roman, part of the Generation X. I started also quite some time in telco development. The younger people or younger folks wouldn't even know. I started in 2G circuit switched domain. I moved then to 3G UMTS and packet switch domain. And in around 7-8 years back, I've started with IMS, MCPTT, this mission critical push to talk. And that was also the days where I get in touch with Kamailio, where our IMS is built on top. And yeah, I like DevOps, and usually when I'm not at work, I'm at rock concerts. Okay, the architecture we are using. It's just a high-level diagram, but you will see that we have the CSCF. All the CSCF nodes in our deployments are based on Kamailio. We run our HSS, which is the database. And we have a couple of application servers, one for normal telco and one for legacy telco, like the MMTel services for forwarding and all that things. And we run a specific one for mission-critical push-to-talk application. And you see the RF interface here. The specificity is that we just have an RF interface from the CSCF, from the SCSCF, and all the information from the application servers we pass through the SCSCF, and we finally put it then into the diameter interface. So on the right-hand side, you have a couple of specifications the RF interface is based on. And yeah, we as said, we do not have, as typically you could also have RF interfaces from the application servers towards the charging systems. So the CGF is the offline charging system. It's from various vendors we have integrated. And at the very bottom, you see the billing system, which we per se do not use, because our customers are mainly using the CDRs for statistical purposes. There is no billing or to pay per se. Few words, online, offline charging. As said, the IMS charging module already supports the online charging. It's for services where you have to to check the credit control during the service. And the network must, let's say if your balance is gone, the network must cut the call or drop the call. While in offline charging, it's event or session record based, and its charging happens after the service. So that means there's no real-time control, and that's also a good thing for us because it's not that complex. And finally, data is stored in the CDRs at the CGF function. The key difference, as said, postpaid and prepaid for the online charging, where you have to check during the service if you have enough balance or not. The logical charging architecture. As said, there's this CTF, the charging trigger function, which we have implemented basically, or which is hosted on our SCSCF. It finally gets triggers due to SIP messages, we will see a bit later, and will then trigger RF messages, which are based on diameter, towards the CDF, CGF, which is typically, at least the vendors we have worked with, in one box. And at the far end, we have the billing domain, which is our billing mediation. And why are we still doing it, let's say, in those days? On the one hand, our customers, which are still networks using legacy technology, GSM, so 2G technology, they have this billing mediation where they have records from this legacy world, and we have to feed basically also records now from the IMS-based successor network, because there are several years where they have to interwork, and that's a good thing for them, that they can correlate calls from one system to the other system. Okay, RF interface. We have, in principle, two diameter messages, the accounting request, which is basically the charging data request, and the answer, which is per se the acknowledge to the request, and it's triggered from the CTF, so in our case from the SCSF Kamailio based, and it's sent towards the CDF function. A few things which are included, but it's really only high level. It contains the SIP method, which triggers basically the diameter message, can be publish, register, which are event-based, or invite. And the answer will contain per se only, only result code if it was successful or not, and it's basically an acknowledgement to the request. Compared what was available in RO. In RO, these messages are basically called credit control request and credit control answer. So CCR and CCA, while here we have ACR and ACA. What else? In the RF interface, like in all diameter-based interfaces, you have the AVP, which is the attribute value pair, also per a specific standards, which will be 23299. What is it? It's structured like the attribute, which is the parameter name, and then you have the value, the actual data inside. While MCPTT is quite specific, because in MCPTT SIP, you have various payload XML bodies which contains these specific information for this mission critical push to talk or mission critical video or mission critical messaging session. And everything goes through our SCSCF, and in Kamailio we pass basically these payloads and extract them and put them into vendor-specific AVPs, a part of the standardized AVPs. Like subscriber info is included, session information, the SIP details again, which SIP method triggered those diameter message, media details, and on top, as said, we have these specificities for the mission critical information. Yeah, we have charging types and scenarios. In the offline charging, you have basically 3 types. You start, triggered by an invite, for instance, and then you have the stop, which is basically due to buy failure or timeout. And on top you have this interim, because if you have, let's say, a long-lasting call, then you have interim updates where you can then create interim records as well. And you have this event-based charging, which is standalone, not standalone SIP messages like publish, register. For instance, in our system, first the user registers in the IMS, and further on, the MCPTT application sends a publish through the IMS towards the application server to publish and to the MCPTT service, and can use it then. So event-based, as said, standalone SIP messaging, and the session-based is basically during calls. Okay, yeah, what are the key takeaways for the interface itself? You have just 2 messages, the request and the answer, which are basically the envelope. Then you have the AVPs, which is basically the information, the metadata, and everything inside, so the value pairs. And finally, this information is parsed to the charging gateway function, charging data function, and there the CDRs are generated and can then be sent towards post-processing, like the billing mediation. Okay, how does the trigger work? So the call flow, I don't know if it's too small, probably. You see it's a session-based charging, where on the left-hand side, the service request, kind of an invite, is received, and after the 200k for the invite, we will see a diameter message towards the charging gateway function. We can have this optional interim, which could happen even during long duration calls, or if you update media or something like that, then you would have this interim record, while when the user or one of the users sends a buy, then the session will trigger a closing of the CDR. And this is basically the session-based charging. The event-based charging, as said, in this case it's just a pure IMS registration, would trigger one record for the user. If you have a publish afterwards, you would see another event, so basically 2 CDRs. Okay, this table gives you just an idea, an overview how we trigger the RF messages. So as said, the 2XX acknowledging an initial invite will trigger this ACR, or an interim will be a re-invite or an update, what I've just mentioned before. The accounting request for the events, as said, as example, I showed you the zip message, zip register, refer, notify, so all those kind of things. And I have also, I think, then later on some further diagrams. And this is basically how it works from the user equipment. User equipment triggers zip messaging or zip signaling. It's forwarded through the IMS, finally towards the CSCF. And the CSCF, as said, based on the triggers we have seen before, will issue these diameter requests towards the charging data function. And finally, on the very right-hand side is our post-processing, however it is called in our case, it's called billing mediation in Kontron. This is also a snippet just to see how it looks like for those who have not seen diameter requests or diameter messages at all. And here you would see that it's an event-based record because it's triggered by the register message from the UE. You have several information in the IMS AVP, and here you have this specific event type that, what I said before, it includes also the zip method which was triggering these diameter messages, and of course you have then all these subscriber identities and information like that, session information inside. This is a bit a kind of session establishment, so a private call, a point-to-point call between 2 UEs. You see on the right side we have this MCX application server. And why is it important? The MCX application server in our deployment acts as a back-to-back user agent. That means you have 2 separated legs, ORIC and term legs. This shows you the ORIC leg. And you see that 2 AC accounting requests are basically generated. So one is here. This is the first one for the called user, and the second one for the calling user. And on the right-hand side, I have moved then from terminating role, because this is the terminating SCSCF, while on the second record it is the originating SCSCF, and both are triggered for due to invites. And yeah, both are basically indicating the start of the record. And this is then when one of the users, in this case it's user equipment B, disconnects the session. And again, you will see two records, two ACRs, because you have one for the terminating CSCF and one for the originating CSCF. This again in a different format that you see. We have CDRs for the ORIC leg and CDRs for the terminating leg. And then the very bottom, this is what you have on our billing mediation, because these generated CDRs have different roles and different information, but they have the same charging ID. That means that the billing system can finally correlate the CDRs and that they are belonging to the same session call. What's important, as said, we are in mission critical area. That's why we have charging must not break calls. That means it really completely separated if there are diameter outages, even though we have HA setup, even with geo-redundant setup, but charging must not break calls. So diameter outages must be handled completely different and independently from the SIP session handling. That's the key for us. Of course, we have retries buffering mechanism, and we have counters to detect alarms or to detect problems through alarms, but at the end, it's important that the call is established under whatever circumstances in our domain. Yeah, how Kamailio helped us. Of course, a majority of the work was there with the IMS charging module. As said, it was only supporting online charging, so our own interface, so we extended it for our needs. It's not yet in production. It's at the moment at one customer under validation, let's say, and if all goes well, then we will anyway issue pull request. Charging module is dependent on, of course, a few other modules, important the diameter ones, and we implemented a feature switch, which is basically used for customers which do not have the need for this interface, because it's also not interesting for each and every of our customers. Oops. There's nothing specific. It's configured like any other diameter interface in XML towards the charging gateway function. One specificity we are doing is for diameter we use SCTP as a transport protocol. We do not use TCP, also due to reliability and robustness reasons. We also have this DB mode, and we only do support one. We basically store all these sessions in a database. In our case, we are using a Galera cluster, which replicates locally, and we distribute also the data on other geographical sites via asynchronous MySQL replication. And yeah, all relevant data for the RF sessions are stored there, and once the session is over, it gets deleted from the database. And yeah, this is what I've just said. You just specify, in our case, this Galera cluster. This RF forced peer, we reused also from the RO interface. It's just good. We use it only for testing purpose, because typically we configure all the diameter peers in the XML, and when you use this forced peer, you cannot use redundancy, for instance. So you force the Kamailio to use always this diameter peer. Expiry also, and a few other, let's say, configuration parameters which are available for the diameter configuration. Yeah, then displays, counters and statistics. Of course, we have also some runtime statistics which are exposed by the IMS charging module, and we implemented specific counters for our needs, which counts initial ACRs, interim ACRs, final ACRs, successful, unsuccessful, all that kind of things. If there are failures with timeouts, so all these counters are basically implemented, and yeah, you can see them here. And of course, we also expose a REST interface towards our network management system, which is based on OpenNMS at the moment. It gives the capability to transfer these counters in various intervals via HTTP or HTTPS. And the authentication for this REST interface can either be credentials, or we can also use JWT bearer token authentication for this REST interface. Alarming, we have two types. Basically, what we also use on CX interface, which is diameter interface towards HSS, specific for the permanent failures. The Kamailio will not use the adjacent peer for any upcoming further messages. Again, these will also be transferred to our network management via REST interface. And then we had an interesting thing, the CDR Gen tool. Why we did it? Yeah, it provides basically via CAM command the possibility to generate massive CDRs without having real SIP traffic. This helped us a lot to validate the CGF throughput, and also finally on the billing mediation side, and we use it still for easy regression and maintenance testing when we do bug fixes on new releases. So that's the CDR gen tool. It has start command. Basically, it's configured in an XML. I will show in a second, if time allows. Yeah. You can query if the tool is running. You can parse the XML file for syntactical errors, and you can kill it if for whatever reason, if it gets stuck or. For this purpose, we implemented two mod palms. So the CDR config file. So basically the location of this XML file, and also we can set a limit, a system limit. Why are we doing that? This system limit tells that the user in the XML cannot overcome this system limit, not to, let's say, kill complete CSF Kamailio just for while running this tool. So that's why we implemented this system limit. And is the base structure of this XML configuration. You have at the very top, you have these iterations, basically how often you run this call scenario. Then you have some common information which will be used throughout all of the scenarios you configure in this XML. And then we have service information which has a limit of 16, and there you can have then specificities for the scenarios. But I'll show you in a second more. Yeah, common information, you have a set session ID called calling party. The called calling party is then iterated depending on the amount of load you set. And you also have the STP offer answer there. And you have then tons of information for AVPs you can set in the service information as well as in the IMS information, which is the MMTEL. This is simple. Just a simple XML snippet for just register SIP users. So that means this, when you run this via CDR gen, it will basically generate two ACRs for the two registers. You have an interval and a delay where we can basically with the interval you can set the call holding time, how long the session lasts, and the delays. How fast the publish or register come each after the other. Okay, let's see if this works. So I will briefly show you how it looks like. I will open. There are two windows basically. On the top, I will show you the XML file, while on the bottom, I will run a T-Shark that you see how this corresponds. First, yeah, let's go to the location of the file itself, the CDR gen XML file, which is you will see we have iterations. I think 10, if I'm not mistaken. You have these AVPs for the common. We have the STP answer offer configured, and then we go down to the service configuration where we have 10 specificities, so we can set the SIP methods like for the events basically which we want to achieve. What else? It's worth to mention. We have all these informations for the invites, basically. So here you set really the AVPs which you want to have in the triggered ACR messages. On the back end, we have a simulator just acknowledging those, so there is no validation ongoing. In this case, in our labs, when we really test a set towards real CGF, then the idea was to measure the throughput on the adjacent node. Here I will just parse the XML command for syntactical errors. It will just show you, okay, how many iterations, what's the limit set at the moment, and as said, this duration, the interval, and in milliseconds, so how fast the registers are considered, and the seconds is basically the call holding time. And now let's, have I set it up? It's so small here. I will do now this Wireshark. Is it stopped now? Yes? It's not doing anything, is it? You don't see it because the progress bar is there. Fuck. Yeah. So I've started now the wire T-Shark on the bottom, and I will just do a start now of this XML file, and you see all the accounting messages and answers basically, which are triggered. On the query, you see the tool is busy, while once it's finished, it will show you the idle state. Okay, key takeaways. The RF interface we have implemented in the charging module provides standardized offline charging for IMS networks. For us, the SCSCF was the best choice for the trigger function, as all the applications are going through it. SIP diameter and CDR is deterministic. So let's say you know SIP input and what you get on the under which circumstances what you get on the diameter output. And CDR gen enables for us repeatable mass load generation without having real call processing. Thank you.
Thank you, Roman. I think I was missing something like the pull request link.
Yeah, it's coming. I told you.
Okay. Questions, of course. Anyone? Ihor.
Sure.
Yeah, to be honest, I've never, thanks first, never worked with IMS, but I've just noticed that you're not logging like setup time, like your start accounting just with answer, which just makes sense, but you're not logging in CDR, not saving any setup time like before the answer.
You have timestamps. Whenever the SIP message arrived, you put it in the CDR, in the diameter, and finally you have it in the CDR.
So you correlate like at the end, like
yes.
The CDR and,
yeah.
Okay.
A question at the back or not? For stretching? Another questions about IMS charging? You want it? One? No? Okay. No. Okay. Thank you, Roman. Thank you so much for sharing this and preparing.
Thank you very much, Daniel. And yeah, first of all, I mean, it is an important date for Kamailio itself, with an important anniversary, but it is also a very important anniversary for me as well, because I mean, this marks my 10th year here at Kamailio World, so thanks for welcoming me here for so long, so that I could pester you all about WebRTC and Janus for so long, even though it makes me a little bit sad, because look how young and fresh I looked back then, so not that young anymore. Now I'm an old monkey, an old guy over there, but still interested in the same things, so I still work a lot on Janus. I've been playing a bit with Quick as well. Some of you may remember from last year I talked a bit about that. And I'm one of the co-founders of a small company based in the south of Italy called Meetecho. And as everybody here, we love standard protocols, we love open source, and we basically everything that we do revolves around that. And we do a lot of consulting services, commercial support around a couple of projects, one of them being Janus, even though today I'll be talking a bit more about another project that we started recently that is called Juturna. And I have to say in advance that this is not a project that I worked on myself. This is really Antonio Bevilacqua's and Paolo Saviano's baby, so they are two colleagues of mine. So I hope I won't mess up anything, otherwise I'm getting a very angry call later on, but hopefully I'll do their work justice. And just to give you basically a bit of a better understanding of how we came up with this project, basically it all started with, basically as most of you did, we needed some form of live transcriptions for our own services. In our case, it was for IETF meetings. And initially, we, as many did, we started experimenting with existing services like Deepgram and stuff like this. So basically getting RTP out of Janus and make it available to services like Deepgram for the purpose. But we really wanted something that we could have more control on, something that we could deploy on premise and do more things with, which is where Antonio came in. Basically, he's a machine learning expert, and he started working basically on a solution to use Whisper around that instead, which he talked about at JanusCon a couple of years ago, a solution that he created called Wispy. At the same time, a few years before, Paolo had come up with basically an idea for a more general purpose architecture to play with AI and machine learning and stuff like that. And that was before this was all the rage like today. So we wanted to play a bit with real-time media and, for instance, sentiment analysis and a few other things that were available, which he had talked about at the previous edition of JanusCon. And so, long story short, the idea came out to try and merge the two efforts. So basically to try to take that vertical solution, that transcription service that we had done, and basically generalize it very much into a much more general purpose architecture, which we could use to do much more than just that. Which basically in a nutshell is Juturna, and I'll talk about it in a minute. And if you're curious about where the name comes from, it basically comes from Roman mythology, because I am very passionate about that. So, for instance, Janus comes from that because it is the gods of transitions, and at the time it made the perfect sense for a component that was translating between the legacy world in quotes and WebRTC, which was the future. And in Roman mythology, Juturna is the wife of Janus, so it made perfect sense to have the two projects have some sort of a synergy between the two. And most importantly, Juturna was also the goddess of fountains, wells, and springs, which, sorry, can you still hear me?
Yeah, you lost it.
Oh, sorry about that. Okay, let's see if this is better now. Yeah, so Juturna was also the goddess of fountains, wells, and springs, which made a lot of sense because basically, as we'll see, Juturna is a pipeline-based component, and so that clicked. And so in a nutshell, basically, Juturna is just to quote the project website, it's basically a plugin-oriented streaming data pipeline engine written in Python. And what this means basically is that we try to make it as easy as possible to take data from live sources like RTP streams or something like that and put that data through arbitrary transformations with using nodes that anybody could bring to the table, basically. Which means a strong focus on real-time data, because that's what we work with, multimedia, because we want audio, video, but not only that in principle, and most importantly, something that could be as generic and extensible as possible. And we really focused on the modular nature of the framework. And we really, the choice of Python was not done by chance, because we really wanted something that was as close as possible to, let's say, the language of machine learning in general. So a lot of models and projects use Python as the core language for that, which means that it should be as easy as possible and as transparent as possible to, let's say, import that functionality into custom nodes that you can add to Juturna to add more functionality, which is why we invested a lot of effort also on making it a very good component for fast prototyping. So anytime we have a generic idea for something new that we want to do with this, it should be as easy as possible to come up with a new node that we can add to a pipeline and do something with that in principle. And this is, of course, completely open source. There are a couple of links there to the repository, to the package that you can find to get it on PyPy, and also to the documentation. Antonio and Paolo did an excellent job documenting everything also when you want to get started and stuff like that. And from a graphical perspective, I mean, it's, if you will, nothing groundbreaking in the sense that it is a traditional pipeline framework, if you want. So you typically have data coming in different forms, and so you have some source nodes that can basically make that data available for processing internally. And then you have different nodes that could be put in sequence, in parallel, or whatever, to transform that data in different ways until you get up to some nodes that can make those results available to the outside world for whatever you need to do with it, basically. And basically, for instance, you could do something, and this is a slide taken from the documentation. For instance, you could have a pipeline where you have audio and video in. You process them both in parallel at the same time, but then the output of audio influences the video, so that, for instance, you have a live transcription of the audio that you relay somewhere, but you also use the live transcription as a subtitle overlay on top of video. Again, a very basic example, but it gives you an idea of the things that you could do with this sort of components. And when it comes to the nodes, let's say, again, it is something that is true for most pipeline sort of projects, but in general, we categorize them in 3 macro categories, if you will, even though in practice this distinction doesn't really exist because all nodes can actually be all of that at the same time. But in principle, we have source nodes, which are basically nodes that take media from the outside and make it available to other nodes for further processing. And this could be, for instance, a node that can receive RTP traffic and decode it so that other nodes can work with the media. Then you have processor nodes, which is where the actual heavy lifting comes in. And you could have different nodes taking care of different stuff. You could have a node doing voice activity detection, another that transcribes, another that does just video detection, another node that does manipulation of bit streams for whatever reason. Again, this could be whatever you need to do, and whatever you need to add to a pipeline. And eventually you end up with, if you need to make these results available to the outside world in whatever format, you typically have sync nodes where you could have, for instance, very simply an HTTP node that shoots JSON out to somewhere, or maybe another RTP node that basically re-encodes whatever the result is into, for instance, an audio or video stream so that you can send it to another component to do something else. And something that we've been working on more recently, and this is more work in progress, but it's already showing promising results, is some sort of we call it a warp node, because basically all of the nodes that I described so far basically start from the assumption that these nodes have some sort of a local access to the resources that they need to work with. So for instance, you have a machine learning model of some sort that is co-located with the process, and you are talking to the process directly somehow to do things, which may not be always the case, because maybe you want a node that interacts with a service that is somewhere over the cloud or whatever, or maybe you want to remotize some functionality of Juturna so that maybe different pipelines need to communicate with each other. Whatever the use case, it's useful to have a node that simply acts as an avatar for remote functionality but sits locally in the pipeline itself, which means that it gets payload data from a local node. It remotizes the processing so that it sends these results somewhere else using protobuf and then gets results back. And then whatever it gets back is what is passed along to the next node in the pipeline, basically. So again, in principle, a very simple thing, but it opens the door to a lot of interesting functionality that could be done. And out of the box, when you download the project from the repo, you get a lot of nodes, basically of the different kinds, a lot of different source nodes, a few processor nodes. You'll see, for instance, a few different alternatives for transcriptions, some plugins to manipulate both audio, video, and so on and so forth, different ways to produce results, and so on. But by no means this should be considered, let's say, a final point. This is really just what we came out with for our own needs or from our own experiments, our own research, and so on. The idea is really that if you download Juturna, really the main purpose is for you to most often write your own nodes out of models that you control or that you created or that make most sense for you for your own use cases, basically. So it's supposed to be as easy as possible to write new nodes in order to enrich the available functionality there. And it's not even nodes that you need to make available. I mean, it's also nodes that you can keep to yourself if you want. And just to give you a practical example of how it works, so basically how we use it ourselves, I mentioned how it all started from transcriptions for us. which is also the most obvious use case for this, if you think about it, because it is a simple pipeline, a simple sequence of steps that you want to do with an audio stream. And we use it in production with Juturna at IETF meetings specifically. And basically, of course, we spent a lot of time trying to make it work as best as possible, and I think we did a good job in order to minimize, for instance, where there were rate hallucinations and stuff like that. And coming to the different nodes, it may be easier to have a look at it from a visual perspective, because basically it is really a quite simple pipeline that is just a sequence of different nodes. So it all starts from an RTP node that takes media coming in from the outside. In our case, it is media coming from a Janus server that using the Audio Bridge plugin, because at IETF meetings, we use the Audio Bridge plugin as an audio conference server that mixes all contributions, both local and remote, which means that the Juturna receives a mixed stream with all the contributions of different people talking in. And this is an RTP audio stream that gets to that audio RTP node over there. That audio RTP node knows the codec it's working with, it can decode it, and can make raw frames available in whatever format to the following nodes. In this case, the first node that we encounter is a Silero node that implements voice activity detection, just to check whether or not we're dealing with silence or not. Next step is the transcriber node itself that implemented on top of Whisper, Fast Whisper specifically. Then the results of that is passed to a further node that we call an aggregator node that's mostly there to clean up the results a little bit, like get rid of hallucinations and stuff like that. And eventually we notify the results. So eventually we end up with a JSON object that has the latest transcription data, and we can shoot it out via HTTP so that it can be displayed somewhere or presented. And all of this has embedded telemetry as well. So we can basically collect telemetry information for further diagnostics later on in order to debug the pipeline, in order to figure out if there are any optimizations that we can do, whether we need to do stuff or something like that. And basically, the end result is something like this, where you have, for instance, the local venue as a second screen, which also shows the live transcriptions of whatever is happening in the room right now. And remote participants have a tab as well, where they can see the live transcription of the session in real time, basically. That's what we use it for over there. And this is, of course, a starting point again for us, because that's where we started, but we wanted to be able to do much more, which is why we came up with that modular architecture in the first place. Because, for instance, yeah, transcriptions are cool, but they can be the first stop towards doing more things. We could do translation, summarization, anonymization are just a couple of scenarios that come to mind. And the ability of, let's say, feeding multiple nodes at the same time, processing the streams in parallel rather than just in sequence and so on, opens the door to a lot of cool things that we can do there. And again, just to show this from a visual perspective, if this is our starting point, where we have a simple pipeline where we go from audio stream to transcribe the stream, we may want to reorganize it a bit, for instance, to again, from the same results, so from that transcribed stream, we can notify it to the same backend as before, but at the same time, those results could be passed to a translator, to a summarizer, and those are processed in parallel so that we end up with more results processed in different ways, all from that same media stream over there. And this is something that we've been working on with a customer of ours specifically. And of course, audio is just the first example, but video makes a lot of sense as well, because there are a lot of scenarios where video does make sense. And in principle, the approach we followed is pretty much the same. So the modular nature of the component is the same, it's just the nature of the media that changes, because of course we all know that audio streams and video streams are not really formatted the same way, where audio is more like a continuous stream of samples. With video, you have timestamped images more than that. But in principle, the processing works pretty much the same way. And for instance, in our case, we initially started playing typically with YOLO-based models for the purpose. And for instance, a use case that we used it for was for a European project that we participated in called Io Ti Vedo, where typically the scenario was quite simple. We had, again, Janus feeding live video to Juturna, so it was still hitting an RTP node, but in this case, an RTP node that was more aware of video rather than audio. The raw frame decoded by the RTP node would be passed to a YOLO detector node, and then this YOLO detector would split the results into different ways, On one end, it would basically pass the raw metadata to a UDP notifier, and I'll explain why we use a UDP notifier in a second. And then it would also pass the, let's say, processed image where, for instance, the results of the detection, like boxes and so on, would generate a new image out of the original image, and that can be turned into a new video stream that you can re-inject via WebRTC, for instance, to watch the results in real time. And the result was something like this, where the use case was, let's say, safety on the job, like you make sure that you are wearing a helmet in a dangerous area or something like this, basically. And having UDP notification as well basically helped us to feed that data via data channels, again, via WebRTC in real time. So it made it much easier for us to work with that. And basically, how do we actually feed Juturna in that sense? And one important point is that we really want to stress out is that even though I made that slide where Janus and Juturna are husband and wife, it's not an exclusive relationship, if you want. Basically, Juturna just needs RTP packets. So if they come from Janus, that's fine because that's how we use it. But really, whatever component can generate RTP, whatever you are using for RTP and can send video to that, it's really fine. But of course, if you can send it from Janus, that's even better. And the way that we do that is basically using a functionality that we call RTP forwarders, where in principle, the name says it all. So basically, with WebRTC streams, we can collect WebRTC streams in real time from different sources. But WebRTC is still RTP on steroids, I like to call it. And so basically, Janus does have access to the raw RTP streams, which means that those RTP streams can be forked and sent to other destinations dynamically for further processing. And for instance, we use it a lot for scalability for our own platform, for Janus, to feed, for instance, the transcription service and for a lot of other things. And the main problem was that originally this was only available in a couple of plugins in Janus, which are the Audio Bridge and the Video Room plugin, which implement conferencing at different levels for audio mixers and NSFU video. And again, that's what we use heavily in our own virtual event platform. So if you ever attended an ITF meeting using our own platform, basically everything is built on top of this very functionality. And basically what we wanted to do was make it available in the SIP plugin as well in Janus, so that even SIP calls handled via Janus could basically benefit from the same functionality in order to have streams forked externally to do something more with that. And basically, just to explain it in a more visual perspective, again, this is how Janus typically works. So in case you're not really familiar with it, basically, the SIP plugin in Janus implements a collection of SIP endpoints that can be created on behalf of WebRTC users, which means that if you have a SIP infrastructure that does know nothing about WebRTC, you put Janus in front of that, and it becomes a SIP infrastructure that can interact with the WebRTC world as well. WebRTC users never see SIP at all. They only see SIP endpoints in SIP URIs and stuff like this. And then they just interact using web-based events and stuff like that with Janus. And Janus is where SIP traffic is originated. So all invites are terminated there, that kind of stuff. The important part here is that Janus is acting as a media gateway also between WebRTC users and the SIP endpoint, which means that it has access to RTP traffic coming from both of them, which means that we can do something like that. So we can fork the media selectively. We can decide which of the streams we want to forward to an external component, how many copies of those streams we want, because we may have different backends interested in the same media. And this is basically all RTP forwarders are. And they open up to a lot of different use cases, interesting use cases. And in terms of how the functionality is implemented and exposed, it pretty much mirrors how it was available in the other plugins. But the important part here is that now SIP calls within Janus have access to the same functionality and additional stuff that you can do with media that other plugins had before. Like, for instance, of course, AI/ML processing becomes an obvious scenario because of the presentation that I'm making right now, but there's much more that you can do with that too, because you can implement now coaching scenarios, monitoring lawful intercept, stuff like that. You could even broadcast a SIP call if that makes any sense. Like, for instance, a SIP call is actually a podcast interview between two people, and you want to broadcast that to a much wider audience via YouTube, for instance. That's something that you can now do using that functionality. You could do external recording without relying on SIPREC if that's an issue, stuff like that. And this functionality specifically was sponsored by a couple of companies, Portadialer and another company that we work with. So we are really thankful for them for actually sponsoring the addition of this functionality. And in a nutshell, basically, this is how it could look like for a SIP call, where, for instance, you have a pipeline where you have two different audio RTP sources, where it could be, for instance, one for the caller, one for the callee. You can process them in parallel, possibly by sharing the Silero and transcriber node rather than having two different copies. This is just for visual simplicity. But in principle, the idea is that this is a potential scenario for instance, transcribing a SIP call in real time using Juturna and then having a diarized, you unify the results from both transcriptions and then you notify them together in a diarized way to an external component. Again, very simple example, but this is something that is now available thanks to this functionality in the Janus plugin. And this is it basically. So in a nutshell, Juturna is a young project because basically I think we first released the first commit we did was probably a year ago or something like that. But in this year, it already saw a lot of evolvement. There were companies that were interested in from the very beginning, and we are working with them already. And so it has evolved a lot. The architecture has changed a lot also from when we first started because, for instance, it was not originally multi-source, multi-sync. It was really a one node in, one node out kind of thing, and now it's much more flexible as a result. And this was really possible thanks to that, again, I'm stressing the fast prototyping nature of Juturna, because basically we had a lot of ideas that we wanted to play with this year, and this was only possible thanks to the fact that we could write nodes very quickly in order to start experimenting with different models on the fly. And I'll actually make a dangerous demo about that later on, and I know nothing of Python, so you'll know how dangerous this is just because of that. And I mentioned how we used it extensively in production ourselves, specifically the transcription part, but there are also some of our customers that are already using it in production specifically for some SIP use cases, and typically contact centers and stuff like that. But really what I wanted out of this presentation was really to introduce the project to you all, because what we really would like to do is to create a community out of this as we did with Janus. So of course, a project is only as successful as the people make it, basically. So if you are interested in this, if you have interesting use cases, if you have models that you want to start using quickly in a real-time fashion, Juturna may help you do that, basically. And the fact that you can write your own nodes in a very quick way should be, let's say, an interesting opportunity to dig into that. And especially considering how young the project really is, this could be the right moment to get in and help us also, let's say, change a bit parts of the architecture if you think it makes any sense. Especially considering that, again, Juturna is meant to be something that you can deploy wherever, even on a Raspberry Pi or whatever you want. So basically, one of the strong points is also the fact that you can really control basically the endpoints on your own. You can put it on premise. You can do pretty much whatever you want with the data and stuff like that. So that's it in a nutshell. And this is it from me. I'll check later if the guys are angry with me or are they happy with me. But if you have any questions, I'd be happy to take them. Thank you.
Okay, thank you. And questions about Juturna we have here.
Thanks for it. So how it is easy to set up this, in containerized environment?
I mean, the setup is pretty straightforward. I mean, it was easy for me because I wanted to experiment with it for the dangerous demo, and so I really just followed the documentation as a dummy user of the platform that had not worked physically on that thing. And it is really very easy to set up because, for instance, you can just use pip to install Juturna out of the box, and you'll get the framework right away. And then creating pipelines is just a matter of launching a command. It creates the pipelines for you and stuff like that. And you can launch them. And I'll also show how you can create a pipeline and launch it very, very easily. Writing nodes is also very quick and fast because basically you have creators that can help you create a stub of the node that you need, and then you just need to fill in the different parts. So implement the different callbacks that need to implement it and stuff like that. So we spent a lot of time to try and make it as easy as possible to get in there and start tinkering with it and playing with it and possibly also break it as easy as possible.
Okay. Do you have any performance metrics available? Like what kind of load test you are tested with this?
Yeah, the performance metrics typically depends on the nodes that you actually use, of course, because those are the ones that do the heavy lifting and so on and so forth. And so, for instance, for the transcription part that we use in production at the ITF, we did publish a paper with some data that we collected at the time. So the platform has changed a bit, so the pipeline has changed a bit, so those results may change. But it seemed to perform. I mean, I don't have access now to the paper right away, but I can share it with you later on if you want. But it seemed to perform well enough. So, for instance, something that I didn't say is that all those nodes that communicate with each other, they exchange payloads, let's say on a contract-based sort of thing. And basically, the data is never copied in between those different transitions. So it's all done with a zero copy idea in mind, which should help with making all those transitions also as, let's say, less impactful as possible with respect to performance. But again, the actual performance assessment really depends on the nodes that you involve and the different things that you do with them, basically. The idea is that Juturna itself shouldn't take that much at all in terms of resources, because it's really meant to be a lightweight aggregator of different things.
Okay, I think it's time for dangerous demo. So Lorenzo will be here. Sorry, you still wanted a question? Okay, a quick one until James is getting set up.
So I was just wondering about the difference between the two different kind of remoting protocols you've got. You're basically running RTP and protocol buffers kind of in parallel. Why two?
No, yeah, the purpose of those two is different, because basically in our case, RTP is acting as the way to get real-time media in a Juturna pipeline. And then within Juturna, how the media flows is a different matter, basically. And then RTP is just one example of how you can source media in Juturna, because we have source nodes that can work out of a file, that can get media via HTTP or whatever. It could be media over QUIC in the future or stuff like that. So that's just how you get media in Juturna itself. And then the warp node plays a different role, because in that case it is a processor node that sits, let's say, within a pipeline. So it has data coming in and it needs to shoot something out to the next node. And in that case, that node may need to refer to a remote model, like, for instance, you want to implement an interface to OpenAI, for instance. And so, of course, you don't have a local OpenAI instance. You need to communicate with it remotely. But you have a local OpenAI node that basically abstracts all that, so that the node before and the node after see a local node they are interacting with. But this node is actually interacting with a remote component.
Okay, thank you. Lorenzo, James, you ready?
Yeah, I think I'm ready. It won't be the first time that the AV team have done a dangerous demo, really. So I was surprised not to be asked by Daniel to participate in the history of Kamailio panel the other day, because I remember the first time I met Daniel. This is back in something like 2005, when I flew to Bucharest and was greeted there by a very young Daniel and an equally young Bogdan, who then drove me and James Tagg to central Bucharest at very high speed, ignoring all traffic lights, which I thought was great fun. Yeah, it was. But we ended up with a demon team working on the TruePhone core infrastructure. Daniel, Bogdan, and then from Free Switch we had Brian and Mike Ferris, of course. Yeah, an absolute ace team. And then, of course, we stuck with Kamailio all the way through, and the main reason for that is it just worked, unlike the AV, which is not working so well. It's probably, is it AV or is it Krunel's?
It's the notebook.
PC.
It's a MacBook. Are we going to convention for the other side too? Yeah.
How we're doing for time? We are already 1 minute behind. So Krunel, hopefully, is going to show us a dangerous demo all about a very dangerous sales assistant agent. Or perhaps he is not going to be showing us that. James, are you ready to roll?
So it's not the MacBook. It's something else.
Wow. Yeah. You had to unlock it.
Stand by.
You have to choose what you want to do.
Well, this is one way of making a demonstration slightly more dangerous. If you can't get it working in another 15 seconds, you're going to have to stand down and we'll put James on. Is it going to work? Okay. Anyway, James, who is, don't be fooled by his Irish accent, is actually a Telnix man.
Can we get the next one?
Yeah, exactly.
Start the laptop and then...
So James is going to tell us all about how to hack mid-proxy authorization with a slide or no slide?
No slide, no.
No slide. So this is definitely dangerous.
Words.
Okay.
This is on.
So, James, you have 3 minutes. Are we okay on the timer? Starting from now.
Okay, in Telnix we've got a number of B2B UAs, free switch servers that make and receive calls for customers. We've got inbound Kamailio proxy server that handles SIP but not media, and an outbound Kamailio proxy server for SIP as well. And they do separate jobs because outbound manages channel limits, inbound manages CPS limits, load balancing in different way, options, dispatcher. So it's all very different. But we got one new vendor who uses UDP for SIP and who required that we use the same IP address for inbound and outbound, and also needed to get us to register for incoming calls and also authenticate all our outbound calls. So the simple thing to do was put another Kamailio server in between as a mid server to handle all traffic inbound and out and still relay between our inbound and outbound proxies. So that was simple, but I didn't want to load the dialog module in just to manage the CSEC updates that need to be done when authorization is done by UAC, and I didn't want to have to load a database, transaction manager, everything else. So I know that the UAC module will change the CSEC numbers on the fly for mid-dialog requests, but that requires the dialog module. So it made sense for me to think instead, if I just get the first invite and lower the CSEC number, then that's going to make everything work. Of course, there's no function in Kamailio for this, so I hacked it. So what I do is, I receive the invite from the outbound load balancer, decremented the CSEC number, send it to the vendor, and when we get the challenge, then add the authentication, hack the CSEC number again. There's a function in the CoreX module, it's new in Kamailio 6, for message changed route, and then relay it. And then it just worked. It just worked every time. And there's no dialog module, no database, no mid-dialog transactions, because the inbound and outbound load balancers do that. And it just works. I don't know how long it'll work, or when it's going to fail, but for now, it just works. And that's it.
Thank you. Yeah, well done, James. Wolfgang, you're up next. So today we've seen the two extremes. We're going from Dan Jenkins with 219 slides to James with 0 slides. So Wolfgang is going to talk about, bizarrely enough, emergency calling. And this time, I've been promised that there'll be no sticky labels on people, but there may be the odd QR code or two. So, can we reset the timer, please? And are you ready, Wolfgang?
Yes, I'm ready. Time is already
running.
running.
You have 3 minutes starting from...
Yeah, QR emergency. So in my spare time, I'm supporting a project in Austria. It's called Tech 112. It's for accessibility. We run an over-the-top application that is standard-based, and you need to install an application. And we were approached by some organizations, like a school or doctors. They said, we would like to have a solution that doesn't require an app to be installed, and it should be something that we can hide, let's say, in a link on a PC that no one sees, that emergency services are requested, like the police, for instance. And there are some situations where you need precise indoor locations or silent alerting things. And the most important thing here is the PSAP always wants to see an identity that is verified. Yeah? So the idea was here, okay, let's combine the location and the verified identity, put this into a JSON Web Token, generate an URL, and use this in order to route it to the most appropriate PSAP based on standards. So just switching to this one. So that's, it's German, sorry. That's the solution that I've implemented during my spare time. So you can set contact persons, like here I have my name and I have the Novotel here. You can set a location. Oh wow, the network is very slow. There should be a location somehow. Yes, I need to log in. Okay, that's the dangerous part here. Oh no. Okay, doesn't work. I'm back here again. So then I can actually I can set a location. This is my office location, and come on, I've prepared a location here for Kamailio World, and I can create a link for that. And this is the web token. And this is the QR code, and the first one who sends a message with a name gets a chocolate from Austria. Sorry. Oh, okay, yeah, come on. You need to press the red button if you see something, and then it opens a chat, and you type in your name, and the first one gets chocolate. You cannot scan? No. Yeah, then. Yeah, press the red button. Oh, yeah, I got a lot. Okay, this was the first one, I guess. I'm hungry. Hendrik, you got the chocolate. Yay!
And that's it. Well, recovered from the brink of disaster there, Wolfgang. Good stuff. And I was about 2 seconds after him. So almost another dangerous demo. Right, I've lost my A&A. You're on. Yeah, get yourself plugged in and give me a thumbs up. Can we've reset the timer? Do I need to introduce Alexander? Probably not. Anita, do I need to? Rita. Why am I calling you Anita? That's dangerous. You'll beat me up afterwards, won't you? That's the dangerous bit. Okay. And who's after Rita and Anita? It's Charles and David who are probably like a coiled spring.
Test.
Are you ready, Alex?
Can we explain it after it? Okay.
No, you've got 3 minutes to do the whole lot.
Okay, so during demo...
okay, are you ready to start?
Yeah, okay.
Okay, let's start. Go.
So yesterday I tried to show you what in the Home 11 we have also some widgets where you can play some games. So just for example, here you can play Packet Defenders. So it's real traffic. It's really, you can send a HEP capture, it will show you, firewall will stop it, and etc. So we also created another game which called dialogue stuff, yeah, blah, 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 okay, blah, blah, blah. And we also created Tetris, yeah. And after I recognized what guys, especially Rita, we play this game, and she liked it, so it's very good. And said, let's create something bigger and make Netris, because it was at my time it was Netris, where you can play to each other. So and now we will try to yes. So and you will see if we will be in 2 minutes.
Very dangerous. Can I try?
No, wait. Alex. Okay, yeah.
No? Yes?
Yeah.
Okay.
Okay, let's go.
Yeah.
So you can play with your colleagues and you Home 11. Because one of you will do a job for you. Soccer. Come on. How many minutes is that? 40 seconds.
40 seconds. It's most points.
Wie ist das Spiel?
Eins ist das Screen. 60.
Yeah, we can see how much time you've invested in Tetris. 15 seconds.
Oh my God. Are there cheat sheets for this?
5, 4, 3, 2, 1. You're dead. Thank you, Alexander. And Rita, who's not Anita. Okay, Charles and David. And after Charles and David, Lorenzo. So this demonstration is called WhatsApp Doc. WhatsApp Doc. So you can guess that there may be a doctor involved in it, a bit of play acting perhaps. Knowing David Duffett, there undoubtedly will be some amateur dramatics. We're reset at 3 minutes. Give me the thumbs up when you're ready.
Okay. My mouse. Yeah. Is there a 3.5 audio? Yeah. It's just there.
Yeah.
Okay.
Are you ready?
Yes.
Just give me the thumbs up and we will start.
I think we're ready.
3 minutes starting from now.
Okay, this is a fictional scenario where there is a health centre that's just used Simwood's WhatsApp integration to allow 3 billion users of WhatsApp to come. Oh, sorry. Thank you.
To use Simwood's WhatsApp integration to allow up to 3 billion users to make contact with the health centre. And when you message through WhatsApp, it's going to go to Simwood Conversational AI. But if you ask to speak to a doctor, or if the AI assistant determines you need a doctor, it's actually going to put it through to Dr. Charles, who's on Microsoft Teams. And that's also part of the Simwood integration. So it won't touch the PSTN. It'll come in via WhatsApp and then end up with Charles. Are we all clear so far? Okay, and the amazing advantage is that, of course, if you're on WhatsApp, you're an authenticated user, you've got secure communication. I'm going to do it on my phone, but I've popped the screen on so you can see the messaging. So first of all, I'll say hello. And can you see I said hello? And very cleverly, it goes blue, look, because the other end's seen it. And then we get a little response, says, I'm James, the helpful assistant at the Kamailio World Dangerous Demo Health Centre. Let me put a little message. Yeah. Okay, I've said I have a nasty rash. Let's see what it says. It says, I'm sorry to hear you've got a nasty rash. Well, I can't diagnose medical advice. I'm just typing another message here, frantically. Oh. Okay, so I said it's on my arm, what should I do? All I'm really demonstrating is that the LLM can give medical advice and talk like that. So now I'm going to ask for a doctor, look. Can I speak
1 minute
to a doctor, please? Now watch what happens, because this is as smooth as something incredibly smooth. So I'm asking to speak to a doctor, and it says, sure, just do the call icon in the WhatsApp chat. So I'm going to do that. And now it's WhatsApp calling. You won't see that on the computer screen. And you should see it's coming through to Dr. Charles on Teams. Hello, hello. There you go, we're through with audio. I would just like to point out, I'd just like to point out that Charles is not a doctor. In fact, he's not even a nurse. But he's a very nice man. A very nice man, a great CTO. I think we're done, James.
And you've got 3 seconds.
What about that?
Well done, David. I wouldn't expect anything less from a seasoned veteran like you. Lorenzo, you're on? Yes. Yeah, and unusually David is participating in a demo because he's normally judging, but I'm sure he'll be returned to judging duties at ClueCon. Now, Lorenzo is yet another person who is a dangerous demo veteran. Have you ever won, Lorenzo? You have, haven't you?
I have won more than once.
More than
I shouldn't boast, but I have won the
definitely a seasoned veteran. And next on after Lorenzo is Cesare, wherever you are. Where's Cesare? Hiding. Over there, right. Again, another coil spring. Let me know as soon as you are ready, Lorenzo. And just a word of warning, next after Cesare will be Dan the Builder. Okay, are you ready now?
Yeah, I am.
You have 3 minutes starting from now.
Okay, yeah, so again, I spoiled it a little bit before.
we just literally talk about that. So I wanted to show how easy it is to create a node with Juturna. Initially, I thought, let's do something fancy like a Where's Waldo kind of thing. And I said, okay, maybe this is way too advanced for me, like working with video and so on. Maybe I could do a Where's James Body kind of thing. But that also sounded way too advanced for me. So I said, instead, I wanted to play a bit with Croco. I don't know how many of you are familiar with it. It's basically the transcription offering by the guys at Zoiper. So you all know Zoa. I unfortunately couldn't be here this time, but we talked often about Croco. I really wanted to experiment with it a bit, and so I wanted to see if I could create quickly, with my very limited knowledge of Python and Juturna, basically a node to start using that, and then try to do a live transcription in real time. And luckily for me, they also offer some community things that I could host on my own laptop as well to test. And so the end result was this. So basically like 100 lines, and a lot of those is basically just the boilerplate, so the stub that you create that creates stuff for you. The actual work is very limited, the stuff that I need to do. I basically just need to interact with the local WebSocket server, which I launched over there. So that is the Croco instance that is local. And then I'll just create a new pipeline with Juturna. So I'll add, sorry, I hope you can still hear me. I'll add an RTP node, we call it audio. The defaults are fine. I just need to make sure that we get float as an output. Then I'll add my, sorry, thank you. I'll add the transcriber node. So this is the node that I created. I'll call it Croco. And this is where we're listening. And then I'll add the...
1 minute.
Yeah. I'll add the sync node for a UDP notifier because I'll use data channels for that. And I'll send to this port over here. Basically, that's it. Then I'll link this. I'll connect audio to Croco and Croco to data channels. I'll save. I'll launch it. Then it should be up and running soon. I can start the
10 seconds.
The demo over here. And hopefully as soon as I start talking, we should be able to see some live transcriptions happening. If I didn't mess anything up. Yeah, okay, something happened.
Oh.
Just in time.
Well, that was a dangerous demonstration in fast and accurate typing, I think. No mistakes. So how you managed you pull that in with seconds to spare. So well done. Very well done. Right, over to Cesare. And I would say yet another seasoned veteran, but that's getting a bit tired now. So Cesare and I go back years. He was but a young boy when we first met, but look at him now. He's running the world, I think. Okay. Give me a thumbs up when you're ready.
Yeah, I'm ready.
So, and this one is called Real-Time Terror. Raw. Are you ready?
I am.
Okay. You have 3 minutes, starting from now.
Yesterday, when Henning showed us the real-time text thing and how hard was it to implement, to get it done on Asterisk. Not because it's a difficult protocol, but because it takes, maybe because the Asterisk is quite complex. I took the challenge and I started poking in it. I actually implemented it in a voice blender that I showed you yesterday. It took me 14 commits, and maybe it's not fully working yet, so I'll give it a go. I'll show you. So this is the I need to. I'll run the voice blender, which is basically now listening for the commands, and then the application that actually connects to the voice blender and does the magic. And also, it's actually 500 lines of code, including comments and etc. So yeah, so I'll have it go. Let's see if it works. Okay, and for testing, I'm going to use this really nice Windows-based application developed in, I don't know, 2010 or something like that, which I'm running on Wine, so it's probably broken. But actually, let me just. It is in a weird state, but let me see. Okay, make a call. Yes, I'm actually connected. I can make a call to the voice blender using WebSocket to WebRTC, and I can probably type a message. And I can probably type a message back. Yeah, and it's there. Whew, it works. That's all.
Well done, Cesare. That was dangerous. That was dangerous.
It works.
And again, that's one of these demos that there's a lot of stuff going on in the background.
Yeah. I found a few bugs that I needed to really fix. I found some functions were not exposed correctly, so there's a lot of fixing behind, but
yeah,
it worked.
It worked. And you know what? If we were doing the Swan Prize, which is for a demo that just works and it's just beautiful, that would be a very strong contender. But we don't have a Swan Prize, though.
Yeah,
anyway, last up is Dan. Dan was really cool about this. He said, yeah, I'll do you a demo, but I'm not going to start writing it until after I've done my talk with 219 slides. So what you're about to see was produced between the end of his presentation and now. And do you have any lunch?
That's not quite true.
Did you have lunch?
I did. Some of it was entire. Why is this not showing the thing that it should be showing? Some of it was written for OpenTips last week, and then I couldn't get the demo working. So this is me fixing it. Right.
Okay. Are you ready?
One sec. Let me get my phone out.
Just say yes.
You open WhatsApp? Yes.
Dan, you have 3 minutes starting from now.
Hello. So this was a demo from OpenTips that I tried to get working last week. So this is WhatsApp calling Voice Blender. Side note, Cesare added WhatsApp support, SIP WhatsApp support into Voice Blender for me within, 36 hours. When I said, I might want to do this, he went and did it. So Voice Blender terminates the audio and the SIP from WhatsApp, and then we then pipe all of that over to PipeCat so that I can have an AI agent that does lots of stuff. And then I've added in it creating a VCON and putting all the data into the VCON. So all of you can do this. You can all message this number. Because you're on WhatsApp, it's free. And you don't have to worry about it. So you can all message it. So I'm going to write hello, badly. And then I'm going to send it my location. Because why not? I don't know. I might have a service that is very location aware. And then I'm going to ring it. So I'm going to call.
Hello. Thanks. Hi there.
Oh, it can hear itself because I haven't put in crisp and all that jazz. So it can hear me talking. So I'm going to ask it some questions. Where am I?
You are in Berlin, Germany. based on the location you recently sent. How else can I assist you?
How many VCONs is in the system based off of the phone number that I called in from?
There are 22 VCON records in the system for the phone number you called from. Is there anything specific you'd like to know?
Right, and then I've still got a minute. So then I'm going to call back, and hopefully it might say 23. There is a slight delay. Hello.
23.
23. Say 23.
Hello. I see you sent a location from Berlin.
I did. Can you tell me how many VCONs are in the system?
You have 23 parts.
Yeah! Right. So that's the end of that. And then we can go over to vcon.store. I can refresh, and then you can see that we've had all these calls. Sorry if you're... Is this being streamed onto YouTube?
Yes.
Sorry. So let's go find one with my number, and then you can see that it's got all the parts of the conversation. It knows where I was, etc., etc. It's got the call recording. It's got the text. And then I just want to go back to this. And this is the most important bit. Voice Blender is less than 3 months old.
And you're out of time.
Voice Blender is Voice Blender is less than 3 months old, and PipeCat is less than 3 years old. So this just goes to show that there is true innovation in real-time communication. Thank you.
Right. I'm afraid you're out of time, but I have some very, very good news for you. And that is, you have won the Crash and Burn prize. So, where did I put it? I've lost my Crash and... No, that's not the Crash and Burn prize. That is not... well, I'll come back to you. It's in a brown paper bag. Yeah. So there we are. Don't show it to everybody because they'll all want one. Okay? So now, my little dangerous demo, the judging for the main prize is being done remotely today by an old friend. And here he is, Mr. Andy Smith. Andy, are you well?
I'm fine, thank you.
And you've got feedback, turn your audio off.
My little dangerous demo.
There we go. Oh, come back.
I haven't gone anywhere.
Is somebody calling me? Whoever that is, stop it. Right, Andy, you've seen all of the entries for this year's Dangerous Demo from Kamailio World. Can you give us a winner? Or can we have the vote from the Bournemouth jury, please?
You certainly can, and I do have a winner. I'm sorry, it's not James Brown, who didn't give us a demo at all. But the rest of them are pretty good overall. But for me, by far the best, because it was live, and he put a lot of effort into it, and he typed very, very accurately. It has to be Lorenzo Miniero.
Hey. So Lorenzo, come and get yet another Dangerous Demo prize. Yeah, you'll have to have a special cabinet made to keep
Thank you very much. Thank you very much.
And thank you, Andy. I think you've got about 10 seconds to give a message to everybody here at Kamailio World.
Well, I hope you've all had a really good Kamailio World this year. I'm sorry I wasn't there. I haven't been there for a few years, but hopefully I will be at some point in the future. So enjoy the rest of your day, Pete.
Okay, thanks, Andy. Okay, and now over to Daniel.
Yeah, so a prize not really like James, he's just awarding another Snom phone. And yeah, it's tough to choose between all the others, but we go for Charles and David. They have to split it somehow. Whatever you decide. And it was a teamwork, and then I thought of integrating all these communication layers in behind.
So that's it from Dangerous Demos. The next Dangerous Demos will be at ClueCon in Chicago in August. If you haven't signed up for ClueCon, do so immediately. And Krubal, I want to see you there in Chicago. Excellent.
Okay, thank you. We have now thank you, James. Sorry, the last prize actually is for James. I almost forgot.
Thank you very much.
For organizing now and in the past many interesting dangerous demos. So
And may there be many more.
Bira.
It's almost beer o'clock, isn't it?
Beer o'clock.
Okay, so thank you for that.
Thank you, James, for all these editions so far. So the last coffee break, we are a bit, let's say, over the time, but we can stay like 25 minutes because, I can finish a bit later. Then we have 2 more presentations, and we still have a phone that I will award at the very end, right, for those that stay in the room. It's yours. Thank you.
Thank you. Hey, I'm glad to be back at Kamailio World, right? All right, Kamailio World 25. Let's go. So, I'm going to walk you through a couple of things that I experienced around MCP, right? So everybody's, and I'll explain what that is, but basically conversational AI chatbots is the thing. People want to use them for all types of things, and I'll explain this in a little bit. I'm going to first give you a little bit of introduction to myself. I've been doing VoIP for about 16 years. Little fun fact about me is that during that time, I worked for a number of like Silicon Valley companies. I worked for Netscape. I worked for Sun Microsystems, Oracle. So I have a salesy background, which helps me a lot. So I did a lot of, I was a sales engineer for many, many years. And also the fun fact is that how I learned about Kamailio was from Fred, by the way. I used to own a restaurant in Detroit, and I had a meetup on Asterisk, and of course Fred shows up at that time. He was like, "Hey man, you should learn Kamailio." I'm like, what? How do you say that again? Kamailio. So it's been a long time, and I appreciate Fred for turning me on to this. So I run a company called D Open Source, and we do open source support around VoIP products. And then we started doing this project called DSIP Router it's been about 7 years now. Maybe even more. Maybe, I don't know. I lost track. And the whole reason how DSIP Router came about was because we kept building the same exact things over and over again. So I decided to package it up. As you all know, when you first start off with Kamailio, it's a little bit of a learning curve, right? So what we do is we package it up so that it makes it real easy for people, right? So it comes with Kamailio, obviously, RTPEngine, a GUI, some bash scripts to do the install. And it's a really cool project that we've been working on for many, many years. I'm going to use DSIP Router a little bit to show you some of the things that we're doing, but this all can be applicable just to pure Kamailio. Real quickly, as Daniel just mentioned, I had to give a quick shout out to my colleague Tyler Moore. He did contribute this P-timer module, which just gives you more precision timing for being able to kick off certain jobs and things of that nature. So I just wanted to make sure you knew that he did some good work there. Super proud of him for taking the time and initiative to do that. All right, so problem space. So we were in a meeting with a customer, and they were like, "Hey," and I always know things are going to go left when they say this. They were like, your UI for DSIP Router is cute." And I'm like, okay. And I'm thinking that they're going to say like, it's missing this, missing that. We want you to add these additional things because people tend to do that. They want us to add a lot of things to DSIP Router. And we're always like, no, it's supposed to be simple for people to use. And if you want something more complicated, you should be hiring somebody to build some type of custom Kamailio configuration for you. But the conversation went left, and he was like, I just don't even want your GUI. I want to be able to interface with it with ChatGPT in particular. And I was like, that's interesting. I hadn't heard that before. And we had at the time had built a little MCP server for DSIP Router, but I wasn't thinking anybody was really interested in it. I just didn't think of it. But it really turned out to be, in talking to this customer, is that they just don't want their engineers having to learn another tool. They don't want them to have to learn the GUI, because they have 10 other tools to learn and understand and update, right? So anyway, so their expectation was that they didn't want to have to, from a management standpoint, have to wait for the support engineer to, and I guess also on top of the operational aspects of their engineers learning the tool, they don't want to have to wait for their engineer to actually grab the logs, look at Homer, all the things you do, right, in order to figure out and give a report to management on what's going on. So they wanted to be able to have more of a self-serve model, where they can be able to access the switches. Now, mind you, the engineers for this company are in the room with us. So they're like, in their head, I can see it in their face, they're like, absolutely not. They do not want these people to have any type of access to be able to do this, and for a number of reasons, right? Because if people have this access, they're gonna start asking all kind of questions, right? Especially if they can just get access to these systems. But anyway, they decided that they wanted to move forward with this. So we started kind of like thinking through how we wanted to do this. And it became a situation where we already had this MCP server we had already built. So I was like, hey, why don't we like use this thing? And they agreed. And so we kind of installed it, got it going, got it pointing to DSIP router, which then obviously routes to Kamailio. And it was okay. I mean, I think it worked okay, but it wasn't the best. And I'll come back to that in a second. So I've been talking about MCP for a minute, and I just want to kind of give you some background on what MCP is. It's a specification that was created by Anthropic. And really, if you look at it, it's just really just a standard way of providing integration to these LLMs, right? So a very standard, very simple protocol. Some people say it's the USB of integrations for LLMs, right? So, and also other thing is that they were tied to ChatGPT because they had just bought their company, all the engineers' subscriptions. But what really was stuck with them was that they didn't want to necessarily be tied to just ChatGPT. MCP is one of these specifications that can be applied to any of these conversational tools, right? So if you look at like kind of the main components of MCP, it's really just three main things. It's really like tools, right? So you kind of hear that a lot of times, like what's this tools? But it's really kind of the hands of your LLM, right? So giving it some ability to do some actions, execute actions on your behalf. Then you have resources, right? So kind of to be able to grab information from systems and present that to folks. And then you kind of have prompts that kind of defines workflows. Like you can give it an action or give it a task to go do something, and it will it's kind of like the playbooks if you're looking at Ansible or procedures in order to do things. So if you look at how does MCP kind of work, this very simple diagram here kind of lays it out for you. So when you first configure the MCP server into ChatGPT, for example, it does discovery to figure out what tools it has access to. And what that does, there's metadata that goes along with that. So when you start asking it questions, it basically gives it context clues on what it should be doing or what it has access to do. And then if you look at the process, once it actually knows what tools that are available, it'll actually register the tools inside of the LLM itself, right? So in this case, ChatGPT. And then it'll take a user request, whatever you wanted to do from in a natural language perspective, like list me all of the endpoint groups that's available, or list me all the providers or carriers. And then it'll take that natural language prompt and then try and figure out what tool to use based on the actual registration of the tools. And then it'll go execute that tool, and then it'll retrieve the data, and it'll process, the LLM will then process the result. So really simple workflow and how MCP works. That's why I think a lot of people have been adopting it. So before I I guess I can talk about that really quickly, and then I'm just going to demo it really quickly. So the V1 version of the architecture that we did for them is kind of like what I said. It was just kind of like a skunk project that we created for just having a basic MCP server for DSIP router. And we initially, it worked okay. But we weren't expecting like 50 people to use it. So, and there's problems, and I'll talk through some of that in a second. But let me just kind of like go over to it really quickly. So this is, I don't know how many of you have like looked inside ChatGPT and actually saw how you can register MCP servers. But I'm in developer mode. There's a little option you can set, and you can define applications. Like in this case, decent router is defined as the application. This is the URL to the MCP server. You can specify if you want authentication on or not. Don't yell at me. Trust me. In our customer situation, they have authentication turned on. Okay, I know all you smart people in the room are thinking like, why is that? But once you register it, it pulls the actions. Basically, these are all the function calls or API calls that it can do. So some of these are tools, some of these are resources, but it pulls all in. This is the discovery part that I talked about. All right. So anyway, so we're going to just. I can ask it some simple questions. Find me a list of, I don't know, let's say endpoint groups. So, and then I can ask it, I can actually tell it to do something. Create a new endpoint group. So in decent router, we have a concept of like, as you know, Kamailio doesn't have any direction per se by default. You have to kind of define direction. So for us, decent router is a very opinionated approach. So we have endpoint groups, or typically are like the user agents, and then you have carrier groups, which is where it's really like the providers, carriers that you're sending traffic to. So if I want to create a new endpoint group, the good thing here is that since I gave it in the definition of the MCP what things are required, it's going to come back and say, hey, I can't create an endpoint group without this information. So I can give it, I can just give it cam telco is the name, and then the IP address is 192. No, I'm just making stuff up. I don't know. And it should go off and create it. I just lost my mic. But all right, cool. So it'll go off and create that endpoint group. And now if I say, you know, I'm lazy, I don't feel like typing again, I'm just going to say, provide me a list of the endpoint groups. And then it'll come back with the endpoint groups. Now, if you notice here, it takes a minute or two. It doesn't take a minute. It takes a couple seconds for it to execute the tool, right? Now, a couple of mistakes that we did here. And let me do this. Let's see. Let's see. Show me the CDRs for. I think I have something in Mac Telco. I think. The telecom. Great. So I don't know where I have CDRs at, but believe me, I have CDRs. And so when I had CDRs, I think I had list of endpoint groups. I had some CDRs in here. I'll go look at them in a minute. But when we did this, we didn't expect people to actually go off and say, hey, give me all of the CDRs for yesterday and compare it to the CDRs of today. So you're talking about like millions of calls, right? So inside of these LOMs, there's a concept of a context window, which some people have alluded to in the last couple of days, right? So if I go back here and I talk through this a little bit, you kind of can get where I'm going, but context windows really matter. And I really didn't understand, I'm not gonna lie to you, I really didn't understand the value and how context windows really worked. So, you know, different LLMs have different context windows that it supports. So for example, I think ChatGPT, it all depends also on the subscription that you actually have with ChatGPT. So if you have a certain subscription, you get a certain amount of context window. And just for those who don't know what context window kind of means, is just, it means is the amount of data that the LLM can actually process at any point in time. So if you're going to get 1 million records, CDR records, and then you're trying to go get another 1 million CDR records and bring them into the context, it's not going to be pretty. And so that's what happened almost immediately. So what happens is that, and by the way, the context windows, just to give you just a scope, I don't think I said the number. Like ChatGPT, I think on the low plan, you get 100K. And then on the bigger plans, I think you get 300K, right? So that's not a lot when you start talking about a bunch of CDRs. Or just, in general, a bunch of different data. If it's like, in our case, at the final version that we created from it actually goes to Homer as well and grabs data. So it's not a lot. So we had to figure out how to architect this properly. But, bottom line is that we had some problems. And so we had to kind of figure out how to solve these problems, because another issue we had was we didn't understand the type of prompts that people would be asking. Because they literally, they can ask anything, right? Because, every person has had their own, ChatGPT account in this company. So without understanding what the questions could be, we couldn't optimize for it. And so that caused problems, because the way we were architected initially is kind of like this. We just had one little server here handling this request, and the server wasn't even sized properly either, right? If you're gonna do this from a enterprise level, you need to properly size the server, or at least have it in a clustered configuration, have it running on Kubernetes, something that can auto scale or something, or give more resources. The other thing that I didn't plan for, I must say, this was something that I was like, what did I get myself into? Is that if it runs out of memory, it just doesn't respond. So if you've ever played with ChatGPT, it starts giving you wrong answers, or because it forgot what you asked, or there's just situations where it just will stop responding. And so we had to come up with another approach. And so the approach really comes down to, and I kind of went through all these lessons here, is that we had to come up with a more robust architecture, obviously. But here goes the other thing that happened. So this happened, we started building this in about November timeframe of last year. If you remember what happened in around December, January time, there was this thing came out called OpenClaw. And it was all this buzz around OpenClaw. And then I wasn't a Claude code person. Like, that wasn't my thing. I just used ChatGPT. If I needed it to write me something, it will go and do it. I'm sorry, this keeps bouncing and it's bothering me. I'm gonna it's driving me nuts. Okay. By the way, I'll just go outside. So we use agents for everything. So speaking of OpenClaw, I swear I'm going to get back on track here in a second. But like in our support channels, we have we have Clawbot that sits there. So whenever we have tickets that comes into our queue, that bot actually has access to our ticket system. We use OS Ticket. So it actually looks up the ticket and compares it to other tickets, and then gives us an output of what could potentially be the issue. So this has optimized us tremendously. We have a little small 10-person team, so having that to do this has been astronomical. So I highly recommend that you get an agent to do it. Okay, anyway, so when this came out, I stopped and was like, yo, we should potentially use skills, because everybody was talking about, building skill files, the MD files that actually lays out what the thing can do and have it. So we were like, maybe we should drop this MCP thing and go do skills. And we realized that skills really are just for defining certain workflows, and it still needs tools, which is what MCP provides, in order to do it, in order to do things effectively. And we needed we just like the approach of having a standard specification that we could easily move. Now, people will argue that you can feed this skill MD file and it will figure out how to create the proper tools to do it. But I think we wanted something more deterministic. We already have the LLMs being non-deterministic. We couldn't have the tooling that we use to be that way as well. So we needed something clear. So we decided to stick with MCP, and I think it was the right move. So all right, so moving to the V2 design goals here. We wanted to decouple the MCP infrastructure from the control plane. So when I say control plane, we there was an API, so with DSIP, everything comes together, right? So we had the MCP server kind of sticking on there, right? So you can't necessarily scale this appropriately, and there's all kind of other bad architectural things that and sins that we did with that. So we wanted to decouple it. We wanted to be able to scale independently from Kamailio. And by the way, they moved from DSIP because based on what they wanted to do to a pure Kamailio configuration. So that also was going on in the background. And then we added some caching layers to this as well. Now, caching, as we all know, can be good or bad, right? I mean, people sometimes, they want real-time data, they want the most up-to-date data, but there's a trade-off between having, up-to-date data, it's not like it's like days old, but just having up-to-date data versus it crashing and having slow and poor performance. Because we all remember the reason why they want to do this is that they like the ability to ask the questions, and it gives it information back in a fast, quick manner. And then we wanted to also reduce the context window pressure that we were having. And then add some observability and logging, such as we weren't logging the prompts that people were sending to us. So we weren't able to figure out why things weren't working in the initial release. Things would just fail, and they'll try and send us their prompt, and we'll try and go reverse engineer what potentially went wrong, but it just became a problem. So we went to this architecture here, where we have a cluster of MCP servers, so it runs on Kubernetes. We have a caching component, and then anything that's not in cache, we'll go ahead and hit the operational APIs that we have. That's the control plane. And then the control plane will talk to the boxes in purple. Kamailio, Grafana, the CDR, DB, talk to Homer if it needs to as well to grab certain data. So this is just a normal, it's not like it's rocket science, but for us, this was a new pattern for us. So we had to figure out how the best architect is to really be able to solve the problem and meet the requirement. If you, I think I just got a couple more slides here, and then I'm off here on stage, is that if you, and I think I already went through this already, the feedback loop is what I'll cover really quick. So remember I talked about we had these prompts coming in, but we weren't really able to get better or understand it. So in the V2 architecture, now we have a feedback loop. So we actually are grabbing the prompts that are being sent to us for whatever request, and then originally we weren't using AI to really get better. We were just sending it to a human to look at these, but now we've started incorporating this into an AI model so that we can more effectively figure out the best way and how to optimize this to answer whatever the question they have, and to also detect patterns in people asking different questions. We just don't want people all of a sudden coming to us and say, hey, I tried to use this thing and it wouldn't work. We kind of want to be able to proactively get better. Really at the big picture of this is really people really want conversational workflows. They want to talk to these systems in natural language. People don't want to wait for an engineer to get back to them. So we're just trying to not get rid of or replace SIP engineers at all, because that would be like replacing my job too. So we just really want to augment it, allow the business to get the information they need in a fast fashion. So call to action. So you can leverage our example repo is here. I know it's in small print. I probably should have had a cute QR code. You can build your own. So honestly, the way we built our first decent router MCP server, I said, hey, ChatGPT, build me an MCP server based on this Postman collection I have. And then it was like, and it created it, and then that's what we used originally. So you can do the same, obviously. And then follow me at Machine Maker. And that's it. Any questions that you have? I'm perfectly clear.
Okay.
I know.
Thank you.
No problem.
Let me, no.
Oh,
I need the microphone
okay.
for giving to the close to. Okay, so any questions about the AI and the integration with what I have as always this models and how long you spend to really find the good ones and the balance between local ones and using those on the cloud with money. Where you?
Well, in this case, the constraint is that they wanted to use ChatGPT. So it wasn't like we had to go, like they had the option to pick one. Originally, we tried to sell them on the fact that why don't we build your own chat client, right? But they were like, no, we don't want to do that because all of our engineers have ChatGPT. We just want to use the subscription we have. And I think what you're going to find is that people are going to pick their camp. They're either going to be in the Anthropic Claude camp or they're going to be in the ChatGPT camp. And they're going to be have a high affinity to one or the other. So we didn't even have the option.
Okay.
Yeah.
So not easy choice. I thought I get an answer because sometimes with one of the providers you hear complaints like the credits tokens, or how they call it, run out very quickly sometimes. Then maybe others are not really integrated as good as in a developer environment as the others. So okay,
yeah,
we still wait to get a definitive answer.
Nope.
Okay, then thank you, Mark.
No
Thank
problem.
You.
Bye.
For the last session, hopefully not very long, it's actually continuing the last year session more or less. So the first 2-3 slides are very similar. As we had quite some significant work and some of it quite recently, I wanted to give an update and somehow show you like the future for some of these let's say, components that we have for transport layers. Then, again, after I will give like another phone in the last giveaways here. So I'm not going to just finish the talk and then we end the event completely. Okay, so let's start. Again, it's quite technical as the first session I did in the first day was a little bit more like summary. Now we get the hands a little bit dirty in some config and more technical details, which I like, and eventually ChatGPT will be trained by those slides and will answer you when you ask about the config file and transport layers for Kamailio. So again, summary, we have a lot of options and you can combine them. We have the address families both right now, IPv4, IPv6 for a very long time. And then the main transmission protocols for the SIP. I could delete the SCTP because I'm not sure if anyone is considering that as really used, some maybe carriers in their core network. But yeah, UDP, TCP, TLS, the classic ones, then the integration with WebRTC, mainly through the WebSocket secure and so on. Just some example, but you'll find everywhere all these options to check the protocol either with variables or with keywords, where you could combine them. So there are different use cases. So security, bridging between internal and external networks, so you can keep your media servers or your PSTN gateways or whatsoever in a private network using Kamailio as a SBC security edge proxy to bridge between, let's say, in this case, TLS and the clear text variants, UDP, TCP being that. You can, of course, switch legacy IPv4, as some people would say, to the newer IPv6, which is actually quite old, even older than Kamailio IPv6, but was not that popular. It's gaining traction, and it's more and more used out there. And, of course, WebRTC to the classic telephones, let's say the SIP classic telephones. And quite new would be this variant of acting as a WebSocket proxy. I'll have it in the last slide, or one of the last slides where we are with it right now. Listing the sockets, sometimes, yeah, you have this listen only without a port and you don't know which ports are selected, or you don't have any listen to actually see what's coming or is listening at that time. You can, use RPC command and you will get the JSON output. Sometimes, I don't know, maybe it's not seeing an interface or whatsoever if you don't put an explicit listen, or if you listen on 000, actually Kamailio will discover the IP available at that moment. So if you have some dynamic IPs and so on, you'll have to be maybe careful and check to be sure you have what you expected as listen sockets. How you specify the sockets to listen on? The classic listen, you can specify it many times with combination of protocol, IP, or interface name. So you can use like 8H0 instead of the IP address, and then port. And this could be optional. Typically, the protocol and port, you can leave it out. We'll use the default port, or we'll use the default transport like UDP. Then there are many transport layer attributes. I put only a few of them, but for TCP, there are a lot, like TCP connect timeout, TCP send timeout, outbound buffers for sending, and so on, a lot of limits. In terms of security, since we had some sessions here, we added maybe like 1 or 2 years ago, a lot of options in the way like, to detect this kind of spooky connection. They connect, but they don't send data, and then they use file descriptor, and they keep you busy. So we have also like option to how long to wait for the first packet, and then also the second layer will be like how long to wait for the entire SIP packet, because the guy could start sending one character by character every 10 seconds, and then you don't really want to do it. That's more or less design of the TCP. We try to do the best at the application layer. Then, of course, you can detect this situation, and probably it's better to block it in the firewall in a way or another, not to get to Kamailio and create new connection if you face such an, let's say, attack. Then more recent, I think 1 or 2 major releases, I added the socket global parameter, which is more like a structure. We have attributes like, or fields like bind, advertise, giving the name. And you'll see for the multi-threading UDP, you can assign also the group of workers for it. So listen is still there, has quite flexible. You can also specify advertise address with the listen. Socket, it's a little bit more structure-oriented. Reminding again, if you don't specify explicitly listen or socket, it tries to discover all IP addresses and listen on them, but only for IPv4. If you want to auto-discover the IPv6 as well, there is a global parameter auto-bind IPv6. Now let's look like what was so far, and yeah, Andre yesterday in the panel about the evolution of the project, he decided on the multi-process, being the first main developer, let's say, of the core, to go with multi-process architecture back in 2001. Again, I've seen the release in 23 hours, so had to do quick decisions. But yeah, has its benefits actually. It's quite lightweight design. You don't need to synchronize on between the workers because they have their own memory space. The dispatching of the UDP packets is done by the transport layer. So one packet to one process. If it's another one to be read, the datagram will be another process. Everything is not done by Kamailio in terms of this receiving and distribution between the processes. But then, yeah, we have this kind of, I put them like concerns or like drawback, where you need at least one process per socket. And I met a situation when there are a lot of sockets that have to be created, sometimes for security reason, to interconnect with different, let's say, providers or carriers, to use different VPNs and so on with different addresses. And creating at least one, but then if you want some parallel processing for each socket, you need at least two or more. And then each process that you create likely needs to go to the database at one or more. And for each database, we'll create a connection. And many face this issue like reaching the limits of the database in terms of active connection. If you control the database, maybe you can tune it, but if you use some cloud provider, it's not maybe always just instantly. You have to ask for more resources and so on. Then, yeah, it's a private memory per process. And then again, if you have many processes, could become significant use. It's kind of virtual, so it's not really visible unless it's really used. But still could be a concern that I have many processes for each process, like 12 megs or 16 megs, and I have, I don't know, 100 processes of Kamailio, and that multiplies the per process memory. So there are a couple of valid concerns with this one. So we have on one side the benefits of lightweight and no, let's say, synchronization locks and so on, but then other resources, they are multiplied. So then last year, and I already had it from the last year, this with multi-threading UDP receiving, what changed actually, there is a single process in this mode because both of them are still available, or the old one is still available, and it creates threads for each socket that you create. So it's a single processor, no matter you have 3 sockets, UDP sockets, or 100 UDP sockets, are threads now inside that process that read the packet, and then they push them in a memory queue, shared memory, and they are consumed based on availability by a group of processes executing the config file. And you define how many processes are the consumers. So now practically there is a single reader and many consumers. All the consumers or those processes that execute the config file can send out, so they don't send back anything to the first process running the threads. Of course, it adds a little bit overhead by putting in shared memory, but typically, if it's a good traffic, ends up in transaction management, which is shared memory. Maybe you can say some traffic that you like keep alive, you send the 200 OK quickly. In this situation, yeah, might be a little bit overhead, but I don't think it's significant in terms of performance impact in any way. So how this is working? Again, the multiprocess is there, it's still the default one. This is the new one, and you can enable it by controlling with UDP receiver mode. And if it's 0, it's the old style. If it's 1, it's the new style completely. And if it's 2, you can combine. So you can have for some sockets create dedicated processes. For other sockets, use this multi-threaded model with worker group of processes. It's actually reusing what we name it at some point in time, asynchronous workers. So you'll have to define asynchronous worker groups. You give it a name and how many processes as workers. And then you have to use the socket. And in the socket, you give this AG name, asynchronous group name. So you say what's received on that socket. And we have also this capability to give a range of ports. So also new last year. Then on all these ports from like 5060 to 5068, so that will be like 9 ports. We'll create 9 sockets, but you'll see they'll be consumed by a single process with threads. For another socket, we assign another group for processing. And you can have, if you don't specify AG name, then we'll create processes based on the children value. So again, we'll have older model, newer model as options, or a mixed model in this situation. And I think it's covering all the needs, I would say, from the point of view of UDP traffic at this moment. Now, let's look at the TCP, and this is how it was so far. Because the TCP has this connection states and so on, we already had like a TCP attendant or TCP main process, which was listening for new connections. And then also was checking if the connection should be timed out because no traffic or other kind of operation, if it's time to close it or send TCP layer, keep alive, and so on. Running in a kind of IO loop, this kind of KQ or ePOL, pols. And then once the connection was accepted, it was only passing the file descriptor. So that process was never handling SIP traffic itself. It was just accepting. I got a new connection. I give it to a TCP worker. We had this from day Andre added TCP support back in like 2001, 2002 because he designed it. So we already had like a pool of processes getting a connection, and then I was consuming from that connection till there was nothing to receive, and then when it was nothing to receive, it was passing back the file descriptor to the main attendant saying, this is idle now. Keep it there. When you get an IO notification, it's data on it. The main process will put it back in the queue for an active connection, and one of the workers will pick it up. There are some, kind of limitations also here, like a very busy connection could keep a worker always engaged. We have then some modules to be able to dispatch between this kind of processes to asynchronous group. So you can have the second layer to dispatch from a busy connection to many other worker processes. But then there was some issue with the libSSL, the bleed, how was called, Sandro?
SSL bleed.
SSL bleed, I think, when everyone discovered that libSSL is used kind of everywhere, but it had kind of bad design or was not maintained. And they created a larger team, they got a lot of funding, and they decided to go more into multi-threading. Heartbleed, so I forgot. And that made it harder for us. We were fine with older version like 1011, everything was running smooth. But from 3.0, they change a lot, like they removed the option to set your own locking mechanism. They made it harder to also work. Memory is still available, but they made it internally using a lot of this thread storage type of variables and so on. So many thread-specific locals fields there. And that made it harder for Kamailio in a multiprocess architecture to deal with. We had like crashes, random, you didn't know from where. And there is another, let's say, issue behind that because libSSL has a global context for the application, but then in Kamailio, for example, you can load HTTP client module, which does HTTPS, and we use the libcurl, which could be compiled with libSSL, and they might do also their own kind of expectation with the memory, like being the system malloc or whatever. I just give an example. So sometimes also connecting to the MySQL, the libMySQL client, if you connect over SSL, it's practically reusing the same library. And then they were reusing the same context. It's why I have this load TLS first, and then Kamailio initialize it for like multi-process kind of, let's say, runtime. And yeah, like 2 editions ago, we had Richard, as he used the European name, but shipping Chan from Singapore coming. I already gave the link to the presentation because he spent a lot of time on looking at the changes, looking at the internals of the new versions, and had a very good presentation here, presenting all this, showing all these, let's say, bits and pieces that affect us. I'm coming back to him a bit later, but this was practically the main concern. Otherwise, we were doing pretty well with TCP TLS. We had asynchronous sending, so scalability was not an issue, but we faced this, and TLS or SIP over TLS or WebSocket secure are very common now, so we need a really reliable layer there. So what we, I was thinking how to make it in the way that, you know, it's more like evolution than revolution, because, you know, when you have a revolution and you need to retest everything from scratch, it's complex. You can introduce bugs and everyone goes, let's say, untrustable on the situation. We already had the TCP main process. It was there, it was having all the file description and so on. And then I said, okay, let's do the all operation encryption, decryption, and quick sending from inside that process. Again, leveraging threads now. So what happens with the new version, when you set these TCP main threads, although it's done for TLS actually, but because it's in that process with the name TCP main, I choose that, let's say, global parameter name. We'll discover how many TCP workers you have, and for each of them, we'll create a dedicated thread. And then between the thread and the corresponding process, it's like a bidirectional communication pipe. So each process will use that thread as a worker for encryption, decryption, and quick sending over a TLS when is the case for SIP over TLS or for WebSocket secure. And now practically everything, the context for the libSSL, all the threads local are in the same process and they are safe to use. And I think there were some people helping me with test. The guys there, because they faced this issue, and actually it's when I started. So Wildix guys, they helped me with testing at that time, and they actually provided very good debugging information that allowed me to identify the real issue. And I think it's quite stable from that moment, because before it was more like random situation when, it's crashing and so on. So this was the first phase. It is in the stable version now, 6.1. It's still defaulting to the multi-process like architecture, you'll have to set the TCP main threads to 1, or you can actually use on, off, or true, false, because these are just keywords in our scripting language, but behind it's 0 or 1. So use any of the values you find easier to read. So we still have that one there. Let's see how long we'll keep it. Just a summary of what I explained it to be in written if you need to look at it. You don't have to do anything for the socket. This is only on the global level. So it was anyhow like a pool of processes for all TCP TLS WebSocket sockets that we had. Only how the encryption, decryption, this libSSL related operations are done. Now in the development version, shipping became also very active. He did a lot of more migration between multiprocess to the multithreading, including accessing the attributes, reloading the config file, and saving a lot of context space. So he moved, or he developed these features to be done more into this multi-threading architecture. He even switched the entire, I think, the TLS Wolf SSL. It's working in the devel version only with multi-threading because he said it's the right approach even for that library. And will be available in the next major release. What I have in mind, because I think it was a conversation between Richard and Henning at some point, because he wanted to make this on default, and then it's creating some threads that will stay if you don't do TLS or WebSocket secure. My idea was, but I didn't have time, it was days before Kamailio World, to try to add an auto mode. When I discover it's TLS or Wolf SSL loaded, and then create the threads. So not to be explicitly set. Now with Wolf SSL is like, if you start it without this set, will shut down, will throw an error, and then indicates in the logs you have to set the TCP main threads to 1 for the module to work. So this is how we tackle this issue with UDP in the first phase, then with TLS the second, and how we advanced over the last months. Again, most of it, and big thanks to shipping for all the work done for like 4 years or even more on this area. He's really taking a lot of time to dig into the version now. He also look at the libSSL 4.0 already, even if it's not in like major Linux distribution. And that really helps us quite a lot. This is a screenshot from his presentation 2 years ago. The link to the presentation was in the previous slides. I mentioned it being the transport layer that also in the development version now have Kamailio acting as a WebSocket client. And this is something that is supported by or sponsored by the SIP front, which I think they left. They want to integrate it for this kind of testing framework they have. So it's quite advanced. We had Kamailio as a server role, WebSocket server role, accepting the connection and so on, but most of the code was there. What's here a little bit challenging, it's when you have to send over WebSocket, you have to queue a little bit the SIP message because you have to do the HTTP handshake for converting to the WebSocket. And now, again, if you, we haven't got to any kind of, heavy testing, but then if it's like hammering Kamailio with a lot of message and text to open the connection, maybe queuing accumulates. So I have to work on that. But we have, or I added 2 layers right now, WS Connect, which returns true if it's a fast connect, and then you can use T-relay or you can use the forward stateless. And then we have the WSend, which is doing the connect, and at this moment is doing stateless forwarding. So WS send is more like WS connect plus forward. So these two practically will be the equivalent of this one. We have two variants for the functions because you can provide it as URL, or you can give it split on attributes like address, port. You have to give the path. So that was a little bit keeping me back to decide how you can use it with like T-relay, because T-relay expects a SIP address, but here besides the target will be host port, you need to give the path of the URL. And that, yeah, could be an extra parameter or some attribute like XAVP or so. So it's there, it should work. What would be the next step is to make it transparent for forward and T-relay. We'll see how it's going. So this would be, in terms of this work on the transport layers, just a few remarks about the SIP exert. Because I extended, I needed it for this testing. So I had to add plain WebSocket because we had only WebSocket secure. And yeah, this has quite a lot of feature. Maybe I'll have to check the Alexander tool that he announced it for testing, because there was no tool with WebSocket when I started the SIP exert. But also added quite some other features that helps testing, like authentication with other hashing algorithms, the stronger one, the modern one. And to be easier to test, I also added kind of scenarios like register and call yourself, or register two users and call between them, but it's the same instance because I wanted to test with this WebSocket and so on. So it helped me. And I added also for presence, but I haven't got the time to test it properly. But again, if you need to use for signaling testing, this could be a tool, and I use it specifically for this implementation. So I'm actually done with the technical slides, and I take the last chance or the last opportunity for this year to thank to all our sponsors, Cifron, Gilava, Diablo.com, Cmood, Sipgate, QXIP, Pascom, Snom, LOD, the partners, Clucon and API Ban, and of course, my company, Asipto, is somewhere in the middle. We put some effort as well. And yeah, I think this year was a good edition, in my opinion, very good crowd. Thank you guys coming, because I know many concerns with all the flights take off or not, and a lot of crisis around the world. We had people coming also like from Australia also this year, so some of them traveling long distance. Maybe it was not really a big party, but we are not younger to have like disco and so on. But I hope you enjoyed last evening with some good beer and wine and food, and all the other, let's say, coffee breaks and lunches met your expectation in terms of selection of options to eat and drink. So really appreciate taking resources for coming here, being out of job, so sometimes it's not easy to convince your boss. But yeah, you filled the room, you made it look like it worth to go for the next 25 years, right? Okay, thank you very much, Stanley. Thank you very much. And as I said, I still have to give some giveaways, so don't, I'll let you say some words if you want soon. But first, since I said some people made really efforts to come here, we had some that travel like 2 days by bus. So you won once, and I give one. They came from Ukraine, 2 days by bus. So you should have a gift to remember this trip. So I know it's a long trip and not an easy one from Kyiv to come here. And then I have a couple of that I want to give directly. Sorry? Suspense. By the number should be no suspense. I know these are like baby size for Bavarian guys. But I think Pascom team deserves. Everything was working fine. I put it like this, right? Thank you everyone, because it was pretty smooth, no real issues here coming for us. The speakers, microphones, all the AV was set up. They have also not an easy trip or short trip because they come from south of Germany. And now the last one to give to the audience, the last non-phone. I'll ask Ramona since he's here and eventually spend a lot of time organizing it.
I'm allowed, yeah? Okay. Let's focus.
So we have Eduardo and you know, short trip this time. Thanks for coming. So I think this is it from my side, and if someone wants to say some other closing remarks, otherwise everyone have a safe trip home, and hopefully the world stays calm enough to see us next year. Probably still Berlin, although I had some question last evening about maybe other location, but it's unlikely to happen at least in the near future. Berlin has a lot to offer, and the best is here inside, right? For this event. Hope you've made good connection, good chats besides everything else. Recordings are already online. Yesterday I saw it in the evening. He made it with the table of contents. So if you missed some of the talks because you chatted outside, you will find them on the YouTube channel. And that's it, guys. Thank you, everyone. It was really